Hey grade 11s and welcome to this video. So in this video we're going to be working on the Maths Paper 2 Grade 11 November 2022 Gauteng Province paper. Okay, so I couldn't actually find the paper 2 of the 2023 paper, but if anybody does have it, it would be very helpful if you could share the link. If you could just upload it onto a Google Drive and then you can share the link. Okay, so just like paper 1, this paper is for 3 hours and it is 150 marks. Again, this is going to serve as a revision for anybody who has not written. So please do bear in mind that the paper may be 3 hours, but my video will definitely not be 3 hours because I'm going to be explaining as well. And here and there, I may just add my own questions, just things that I feel like they could ask based on the scenario that they give you. Okay, so without wasting any more time, let's get into the first question. Okay, so this is what question 1 says. It says, the data below is the annual report from the local municipalities regarding the spending of money in thousands of rands on electricity. Okay, so spending on money in thousands of rands on electricity. So these are the amounts. The first question asks us to draw a box and whisker diagram of the data above on the attached answer sheet. Okay, so I'm going to go look for that answer sheet as well. So we just have to draw a box and whisker diagram. Okay, so the first thing you need to remember when drawing a box and whisker diagram is, first of all, your data needs to be in the order of smallest to biggest. Okay, so it needs to be in ascending order. So we need to first make sure that everything is in ascending order. So when I say 250 to 66, it looks fine. Okay, until I get there. So, and I can also see a 294. So this is not in ascending order. We first need to put it in ascending order. Okay, so let me just make some space so that we can just have space here. Okay, so I found the answer sheet A that they were speaking about. See, they've already drawn a number line for you. So now you just have to put it in its ascending order first of all, and then go ahead and find your 5-number summary. Okay, so let's put it in ascending order first. So what would be the smallest number here? Well, I noticed that 250 in the 50s is the smallest number really. Not really seeing any 240 anything. So 250 is our smallest number. You see, when you write down that number, make sure to scratch it out here just so that you know, okay, you're done with that. So I'm done with that. Then the next number that is the smallest, I'll be looking for something in the 250s. I see 259, okay, nothing else smaller than that. That's 329. So 259, 259, and then I'm going to scratch that out. Then, okay, because that was 259, the next ones that will be the smallest is in the 260s. I see that one and I'm not seeing anything else there. So 266, that's done. Anything else in the 260s? No. 270s, okay. 277, okay, then that's next. 277, that's gone. And then we have in the 280s, 287 and 287 again. Now, what else? 294. So 294, done with that. And now we're in the 300. So 306, 306, scratch that out. And then 315, scratch that out. Lastly, 329. And as you can see, there is no other smaller number here. Okay, so that's it. Okay, so now that it's in ascending order, always make sure to put it in ascending order. If not, it's not going to really work because you're looking at quartiles and stuff. Because we need to draw the box and whisker diagram, there's some things we need to figure out first. Now, I know I should have probably drawn the box and whisker diagram, like push this on the bottom, but it's fine. I'm just going to do the calculation here. You're going to have to find your 5-number summary. So find this 5-number summary. The 5-number summary is made of the following. The first is the minimum value. That's the smallest value. Okay, and the minimum value here, as we can see, not in this is 250. So our smallest value is 250. And then number 2, it is the lower quartile, which is of course Q1. And we have to find that. Now, the thing about the lower quartile is, in order to find the lower quartile, you first have to find the next thing, which is the median. Okay, you have to find the median first, which is your Q2. And then the fourth thing, of course, to find would be the upper quartile, which is Q3. And then lastly, we have to just find the maximum value. And the highest value in our data is 329. So 329. So we already have at least the minimum and the maximum. So in order to find any of the quartiles, the lower and the upper quartile, you first have to find the median. If we can find the median, we can find them. So in this data is not that big. So it's actually easy to find here. But I'm going to show you the two methods of finding it, because sometimes you get a data that is a lot. You get a lot of values, and sometimes you get a data that's not that much. So let's start with a simple way where they give you a data that you don't have a lot of values, like this one. Let's look at the amount of values that we have. So if you count the boxes, you'll notice that you have 10 values. So the median is really just the middle, okay, the middle value in this data set. The easy way of calculating it when your data is not that much is like this. We're just going to try and go from the left and the right to the center of this data. And this is how I'm going to do that. It's like I'm going to scratch out the first and the second. I'll remove those scratches soon. And then second and second. And then third and third. I'm just trying to get to the middle. Fourth and fourth. And then I see that there's actually two numbers in the middle. It's not just one number. So how do we find the median here now in this case? Because we have two numbers in the middle, what we're going to do is we're going to take those two numbers, we're going to add them together and then divide them by 2, because you're trying to find the middle. So the middle is not this number or this number. It's actually the number in between them. Okay, so that's how we're going to find that median. Median, we'll calculate it in this situation by saying 287 plus 287, because it's really just the same number there, divided by 2. Oh, if you put this on the calculator, which you don't really have to, it's the same number, double of the same number divided by 2, it's still going to give you 287. Okay, I just want you to realize that this 287 is not this one or this one. It's just the in-between of them. The median lies here. So that's the 287 that we're getting as our middle value. Okay. Okay, now remember I said I'm also going to show you another way of doing this. The other way of doing this is by using the median's position formula. Okay, so if you wanted to find Q2, which is really the median, if you want to find the position of Q2, you're going to use this formula. So it is n plus 1 over 2. Okay, now what is the n in this? The n is really the number of values that you have. Number of values, that's your n. So this is just to find the position of Q2, okay? Whether it's the first, second, third, fourth, fifth, and so on. Which number is that? Okay, so n, how much values did we have in this data set? We had 10 values. So we would say 10 plus 1 over 2. And so this would give us 11 over 2. So 11 over 2 is really 5.5. You can even use your calculator if you want to. So what does this mean? Well, if it had said just 5, then it would mean that in your data set, you would just take the fifth number. But this one is saying 5.5. So this is what you're going to take. You're going to take the fifth number, and you're really just taking the number in between the fifth and the sixth number. That's why it's 5.5. So like here, we'll look at our data and we would have to count. We would say 1, 2, 3, 4, 5, and we need the in between of it. So the minute it says 0.5, 5.5, just know that you're already going to take the fifth number plus the sixth number, and because you want to get the middle of it, you're going to divide that by 2. Okay, so you see, it still gets you the same answer. We will still take the fifth number plus the sixth number divided by 2. And again, we will get 287. So I'm just showing this method just in case your data is actually a lot, where you have a lot of values. Okay, so that's just the other way to find the median. So like that. And so we know our median now is 287. I'm going to put that down, 287. Now this is what I meant by, in order to find Q1 and Q3, sorry, you need to first find the median. This is what I mean by that. Now that we've found the median, the middle of our data, let me even get rid of these now, I don't really need them anymore. Now that we've found the middle of our data set, that it's in between here, this is what this means now. This means that from this number 250 all the way to this number 287, not that one, okay? This is the middle, all the way to 287. This is going to be considered as your lower half of your data, okay? And that means from this 287 all the way to the 329, that's going to be considered as your upper half of the data. Now, Q1, or the lower quartile, is really just the middle. It is the middle of your lower half of your data. And Q3 is also the middle of your upper half of the data. Now, this one you usually don't need a formula to calculate it, because by the time you half that data, when you're looking at the lower half, it's not going to be that much numbers. So we just have to find what is the middle number here. And so if we did the same method, trying to get to the middle, first and first, seconds and second, we'll find that this is the middle number. So here is your Q1, 266. And so we could put that down. That is 266. And then where is our Q3? Do the same thing here. Get into the middle. And there, this is your Q3, 306. So 306. And there, everything is completed. We have our minimum value, Q1, Q2, Q3, and our maximum value. Okay. And now we can finally draw the box and whisker diagram. Okay, so let's start putting that down. Don't mind this. I just put this here because I wanted more space here. Okay, so the minimum value is 250, and I can clearly see it nicely here, 250. So for that part, the box and whisker diagram, it really just looks like this. It's a dot, a line, and like this really. Okay, that's what a box and whisker diagram looks like. So for the 250, that is the minimum value. That one is over here. It's going to get a dot. I'll put a dot for the minimum value. And then for the lower quartile, Q1, that is 266. That's going to be one of the lines standing up like that. Okay. So that's 266. I'll go all the way to where 266 is. As you can see, we have 265. So after it is 266. So I'm just going to put a line. But obviously, they don't know that that's 266. So you have to write that down right here. I'm going to say that is 266. So they know, okay, there's my Q1. And then we have the median, Q2. The median is 287. So where's 287? 280 is here, 285, 287 would be maybe somewhere like roundabout in the middle-ish of here. So I'm also going to put a line down for that. And because I can't see the number here, I have to write it down, 287. And then Q3, upper quartile, is 306. 306, here's 305. So just immediately after is 306. I'll put my line down and write 306 because they obviously wouldn't know that's 306. And there. And then lastly, the maximum, which is 329. 329, here's 330, just a little before it would be 329. So there's my line. And I have to write it down because the number is not showing on the number line. So 329. Okay, yeah, it's kind of there. And so, sorry, it's not a line. Why did I put a line? It's a dot. It's the maximum. Okay, so 329, and I'm going to have to put a dot. Try to make it in line with that dot as well, just so that your box and whisker diagram looks fine. Use a ruler. And now that we have this, we're just going to have to connect our boxes. So I'm going to connect the boxes, the three lines standing up like that. You connect it like that, and you connect like that as well. And then when that's done, you're going to connect the whiskers, okay, those dots. So we're going to connect that to this box and that to this box. And there we go. That's our box and whisker diagram. Okay, so that is question 1.1, drawing the box and whisker diagram. And then we move on to question 1.2. Moving on to 1.2, 1.2 says, comment on the skewness of the data. The skewness of the data. Okay, So how do we find out how skew this is? Well, because we already drew the box and whisker diagram, they want you to use that, okay? There's really two ways of finding the skewness, but the one way is using the box and whisker diagram. So we're going to use this, and we're going to have to see between these quartiles, you're going to have to look at Q2 and see if it is closer to Q3 or closer to Q1, sorry, to Q1. Okay, so if it is closer to Q3, this is how it's going to work. First of all, when looking at the skewness, it is a little different. I want you to imagine it like this. Just pretend you kind of turn your back towards the page, right? So if you turn your back towards the page, then what will this hand side be? Okay, so if you turn your back towards the page, this is your face, this will be the front. And so what will this hand side be? Is that your left or your right hand side? That will be your left hand side now. Okay. And again, this one would be your right hand side. So if you notice that this line of Q2 is closer to Q3, then it means that your data is skewed to the left. And if you notice that Q2 is closer to Q1, then your data is skewed to the right. Okay, so that's what you have to focus on. And you can see they're really trying to test whether you actually understand this or not, because you see the way the information looks. If you had just looked at it and said, oh, this looks as if it's right in the middle, then it may not be correct. So you need to be careful when working with this. Okay, so let's find out how skewed it is. Now, right now, when I'm looking at it, it actually just looks like it's in the middle. But you cannot just assume because it looks like it's in the middle. You have to find out if it really is in between these. Is it right in the middle of Q1 and Q3? And this is how you're going to find out. If it is more skewed to the left, right? If it's more skewed to the left, what you would notice is that the distance from Q2 to Q3, okay, is going to be shorter than the distance from Q2 to Q1. So the best thing to do right now is to just start finding those distances. So I want to see how close these two numbers are. How close is 287 to 306? Okay, and we can just do that simply by subtracting. I can say 306 minus 287. So let me just see what I'm going to get there. So if I say 306, just to see how close it is, 306 minus 287, I get 19. So, okay, the distance between these two is like 19 units, right? And then I can also do the same for this. I want to find out how close or how far apart these two are. So I'm going to also just find out between these two. So I can say 287 because it's the bigger one. 287 minus 266. And I get 21. Okay, so let's look at those. Which one is closer? It would be this one. Q2 is actually closer to Q3 than it is to Q1. So how is this data skewed? It's skewed to the left. Okay, that's how you find out. So don't just look at it and assume. You need to check. Sometimes you actually have to do just check the distance between them. Okay, so it's skewed to the left, and I'm just going to write that down, that the data is skewed to the left. Okay, moving on to the next question. Okay, number 1.3 says calculate the standard deviation. So we have to calculate the standard deviation of the data. Here are the steps to calculate the standard deviation. Okay, now I'm putting down these steps because my calculator is a little different here. Okay, this is not the normal Casio calculator. I downloaded this. Sorry about that. I downloaded this on the Google Play Store, so it's not really the normal calculator. So first of all, on your calculator, you're going to go ahead and press mode. Okay, so press mode on your calculator, and then it's going to give you about 3 options. You're going to go for option 2 that says stat. Maybe your calculator doesn't have it as option 2. Just make sure you choose the option that says stat. So, and then after that, we're going to see an option that will say 1 VAR. Okay, so it's just one variable kind of data. You're going to go for that one. Okay, Then you're going to fill in all your x values that you have. So fill in your data values, all these x values. You can go ahead and fill that in. Okay, so you can put it from here, it's fine. It doesn't matter the order of it in this case, because this one, well, we're just finding standard deviation. The order does not matter. So you can even put it in from here. I'm just going to put that in now. Okay, so I've put that all in. Now you will notice that yours would probably have numbers on the side here. Just make sure that you do end at number 10. So you know that they are actually 10 values. Okay, it just tells you the number of values on this side. Okay, then after doing that, the next step is we're going to now press AC, Shift, and 1. And then you're going to get about 5 options, and you're going to have to go for the option that says VAR. Okay. And lastly, you see an option that says that, okay, that's for standard deviation. It's really saying standard deviation of the X values, okay, that you have put in. So you can go ahead and choose that option, and let's see what you get. Okay, so when I do that, I get the answer 23.773. So I just need to round off to 2 decimal places, because they didn't really say anything here in the instruction. They do say round off to 2 decimal places. So it means that our standard deviation is just 23.77. Okay, so there we got our standard deviation. And moving on to the next question. Then question 1.4 says, how many municipalities are within 1 standard deviation of the mean? Okay, this question tends to show up a lot. Let's go ahead and find 1 standard deviation of the mean. This is how you answer this question. So we're going to see it like this. We need to find out how many municipalities, so we will count them afterwards, are within 1 standard deviation of the mean. Well, first of all, let's find out where exactly, or what numbers, between what numbers is 1 standard deviation of the mean. And this is how we find that. You see, you're going to take the mean. The mean, meaning we actually need the mean. We should find that, okay? So you're going to take the mean, and if you're trying to look for a standard deviation of the mean, a standard deviation of the mean works like this. It's like you're starting from the mean, and you're just from the mean, you're moving a standard deviation away from the mean, just 1 standard deviation away from the mean. Okay, so if you are moving 1 standard deviation away from the mean to the right hand side, it really means that you have the mean here, and then you're adding a standard deviation. Okay, so that's going to give you the mean plus the standard deviation. Now, that's not the only thing that can be the mean, 1 standard deviation of the mean, because this one I just went to the right. I just went 1 standard deviation more than the mean. I could also look at it as going a standard deviation less than the mean. Okay, that will be 1 standard deviation from the mean. So in that case, because I'm moving to the left, I would subtract. I would subtract by a standard deviation. And so a standard deviation from the mean would be, we'll take the mean, and we minus a standard deviation. So these 2 values show you about, they really just tell you they are a standard deviation away from the mean. Okay, so it'll be this and that. So what tells you about data that are a standard deviation away from the mean would be if you said the mean minus the standard deviation, and also if you said the mean plus the standard deviation. Okay, it really just tells us about the distribution of the data. So this is what is classified as 1 standard deviation of the mean. Now, let's look at the information. The information is saying how many municipalities are within, okay, 1 standard deviation of the mean. So we're going to have to find out, when we find out what this number is going to be, we're going to have to find out exactly how many municipalities would fall within these 2 numbers. And when I say within these 2 numbers, it means that the municipalities, we must count the municipalities that are first of all greater than this value that we will get here, and the ones less than this. Okay. So it's really just the numbers, the values, how many values are greater than this number, but less than this number. And as you can see, for us to even do this, we need to first of all find the mean, because we don't even know what the mean is yet. Okay, so you can actually use your information. This is only worth 3 marks, so you don't have to now go and take all this data and now start dividing by the number of numbers that you have to find the mean. You can use the calculator to actually find the mean. Okay, so let me show you how to use the calculator to find the mean. Okay, so on your calculator, you probably just have the value of the standard deviation. You can immediately just press AC Shift 1. Even if you just pressed Shift and 1, it was going to work either ways. And then you can go for the option that says number 4, VAR, and then go for the option that has the mean on it. Okay, go ahead and see what your mean is. So our mean is going to be equal to, let me just find that on my calculator. Okay, when you go for that option and press is equal to, you will see that the mean is 287. Okay, so now that we have the mean, we can actually answer this question. So we're first of all going to find out one standard deviation of the mean, okay, those values. So again, that is the mean minus the standard deviation. So we're taking 287 minus the standard deviation, which we got 23.77. And then we're also going to say the mean plus the standard deviation. Okay, now the good thing is, even if you are on the statistics setting, well, you know, as you have on your calculator, you can still do normal calculations and it will still work out fine. Okay, sorry, I noticed I put mean there. That's the mean. So you can still do normal calculations. So say 287 minus the 23.77 and see what you get there. And when I do that, I get this number 263.23. And then I'm going to do the same with 287 plus, I'm going to change that to a plus instead, plus that, and I get 310.77. Okay, so now we have this number. Remember, we just have to find out in the data above which numbers lie within this. Okay, so it first of all has to be greater than that number, but less than that number. So we're just going to find out how many numbers fall within these two numbers. Okay, so I'm just going to keep looking at these numbers and see which numbers fall within these. So first of all, 250. Does it fall within this? Is it greater than this number but less than this number? No, it's not even greater than this number. So 250 is not in. What about 266? Well, it's greater than this number and it is less than this number. So we're going to take that. Let me even mark it in red. 277, it's greater than this number but less than this. So we're taking that. 287, greater than that but less than that. So we're taking it. Also 287 again. 259. It's not even greater than that, so we won't take it. 306. It is greater than this, but less than that, so we're taking that. 315. It is greater, unfortunately, than this. You see, it's not less than it, so we can't take that. 294. We will also take that. It falls within that. And then 329. We cannot. It's outside of that. Okay, it's not even less than that. So there, how many numbers? Now you just have to count how many numbers are these. It's 1, 2, 3, 4, 5, 6 numbers. 6 numbers is our answer. So we can't really just say 6 numbers. Those are the amounts that the municipality spent on electricity. So the question was how many municipalities? So how many municipalities was those? There were 6 municipalities that fall within one standard deviation of the mean. Okay, so that is our final answer. And then moving on to the next question. Okay, and then now question 1.5. They say determine the semi-interquartile range of the municipalities. Semi-interquartile range. Okay. You see the word semi? The word semi, it just means half. Okay, like a semicircle or semi-annually. Okay, so it just means half. And then there's another word that actually looks familiar here, and that's interquartile range. Interquartile range is the IQR. And how we calculate the IQR is by saying Q3 minus Q1. Okay, it's the range of the quartiles. Just like if you wanted to find the range of a data set, you would say the maximum, the highest minus the minimum. Okay, highest minus lowest. And so interquartile range would be the range of the quartiles, Q3 minus Q1. But they want the semi-interquartile range of the municipalities. So you're going to find the IQR first, but you need to find the semi of that. So remember, semi means half. So just divide that by 2. That will give you the semi IQR. Okay. Okay, so let's go ahead and do that. Okay, so we already do know what Q3 and Q1 are. So let's just take those values. Q3, we already know that that is 306 and Q1 is 266. So 306 minus 266 is what we find first. 306 minus 266. And then we just divide that by 2. That's all. Okay, so you can go ahead and do that and let's see what we get. Okay, when I calculate that, I get 20. So there we go. So that is the answer there. And that is it for question 1. Question 1 is worth 12 marks. And then we move on to question 2. Okay, and now we're on question 2. Question 2 says, 32 learners wrote a mathematics test and the results are shown below. So we have group data really in this situation. And as you can see, there's some things that are missing. Okay, but this is the cumulative frequency, and then that's just the frequency on its own. Then we have the marks in classes. Okay, so 2.1, sorry, 2.1, we have to find the values of P, Q, and R. P, Q, and R. Okay, so those are just the missing letters. How do we find the values of P, Q, and R? So first of all, they gave you a cumulative frequency. And they gave you a frequency. If you know how they are added up, you'd be able to easily find these. This is how these are added up. You see the frequency. We're going to take that frequency and we actually just push it over to that side. So whatever number is here first, only do this for the first number. You push it over to that side. So it means that the value of P here is just 5. Okay, because it's really like it is an accumulation of the frequency, really. Okay, so when we're adding up the frequency in the first class, there's nothing else to add up but the 5. So we're just saying, okay, we just have 5 so long. So that's the value of P. P would just be equal to 5. And then if we keep going, this is how these still get added up. You're going to take whatever number that you have here and you add it to the next frequency. Then you get that number. You see, that's why 5 plus 5 is 10. Because it's an accumulation of the frequencies. We're just accumulating the frequency. Okay, so that's 10. And then again, if you said 10 plus 10, you get 20. And then if you said 20 plus 7, you'd get Q. So 20 plus 7 is equal to 27. And that's how we get Q. So Q is 20 plus 7, which is 27. I'm sure if you just wrote the answer, it will be fine. They will know that you know how to calculate it. And then if you take the 27 plus 3, you see we get 30. 30 plus 1, 31. 31 plus R gives you 32. So this is one that you kind of just have to write it as an equation. 31 plus the R would give you the 32. So what would R be? Sorry, if you say R is equal to, just take 31 over. So 32 minus 31, R is actually equal to 1. So that's the frequency we have here. It is 1. And there we go. So we have everything. We have P, we have Q, and we have R. Okay, moving on to the next question. Then question 2.2 says we have to draw a cumulative frequency, an ogive of the data on the grid paper provided in answer sheet B. Okay, so here is the data, really, that sheet. I've already just put it down here. So it's good when they give you these kind of things because at least your calculations, or really the way you're going to draw this ogive, it's not going to be that off. It's probably going to be more accurate. But also remember the questions that they ask here, there would usually be a range of answers they would accept. So even if you were off by like one number, this is like when you're finding things like the median or Q1 or Q2 or a percentile, okay? It's still going to be fine, even if you're just like one number off, because there's a range of answers they will accept. Okay, so I just wanted to say that so that you know it's not going to be a problem if you just get one number off. So we have to draw the cumulative frequency graph on this. Okay, here's how to draw the cumulative frequency graph. you're going to have X and Y values. As you can see here, you have the marks and then you have the cumulative frequency on the Y axis. How you're going to draw this is like this. Please note whatever number you have here, okay? Because this is the marks, this is going to be your X values. You're going to take that number and the Y value that is going to go with this is going to always be 0. That's something that you should always just remember. So meaning your first point is really 20 and 0 as your cumulative frequency value, your Y value. So it's going to be like this. On our graph, we're going to go to 20 for the marks, and then we will stay on the x-axis, 20 and 0. And then after that, all of these numbers are going to work like this now. So the 30 is now going to go with the cumulative frequency values really. It's going to go with 5. See, 30 and 5. You can plot that down. So where's 30 and 5 going to be? This is 30 and then 5. This is counted in twos. So this is 2, 4. This is 5 in between here. So 30 and 5 is somewhere here. Okay. And then next number, that is going to be 40 and 10. 40 and 10. We're going to plot that down. 40 and 10 is here. Next number, it's going to be 50 and 20. 50 and 20, those are two nice numbers at least. So that's going to go here, 50 and 20. Plot that down. Okay. And then we have 60 and 27. 60 and 27. Where's that going to go? 60, 27. We're going up 26. 27 is here. Okay, 60 and 27. And then we have 70 and 30. 70 and 30 would be like this. So 70. And then 30 is quite high up there. So 30. Okay, and then we have 80 and 31, just above 30. 80 and 31. 80 is here. 31 is just one higher. That's 80 and 31. And then lastly, 90 and 32. 90 and 32. So 90 and 32. Okay, so that is done. This is a very nice graph they gave. The numbers were not difficult. Okay, then you're just going to join your ogive. So when we join this ogive, it's going to be from here and we're going to curve. We're just going to join it. It's going to be like a curve really. Go down. Just try to keep your hand steady. And down. Okay, so it's going to somewhat look like a curve, kind of like an S, and an incomplete S. So it's just going to look like that. And there we go. So there we have drawn the ogive. Next question. Okay, then the next question says, use the cumulative frequency graph to determine the value of the median. Okay, using the cumulative frequency to find the median. So first of all, we can find the position of the median and then find out exactly where it is. So remember like our single data when we were finding the median, right? We were finding the median of these values, okay? These are considered as our X values, okay? Those are our results. So to find the median, also please do remember that you shouldn't be surprised if the answer is an X value, okay? Because these are really, that's actually the data that we're looking at, the marks. So to find the median, we can first of all find where the median is going to be. So we're really just finding the median's position, Q2's position. Okay, now when we find this, this is how it works. It's the same formula we can use like in the previous one to find the median's position, which is n, which is your number of values, data values, plus 1 divided by 2. Okay, so this is the standard accepted one that you can just continue to use throughout. So what is the value of n? The value of n, remember that is the amount of data that you have. Okay. Now in this case, this is group data. So you cannot count it and say, oh, I have 1, 2, 3, 4. That's not the amount of data that you have. Okay. The data of these, they've been grouped together because there were just so much people that lied within or that lie within a specific class. These are the results, okay, of a mathematics test. So it just means that there are like 5 people who got within like 20 to 30 and 5 people who got within 30 to 40. We're not gonna now look for each of them because they've already grouped them. So think about it. If 5 people were here, 5 people here, 10 people here, 7 people here, The amount of people, okay, or the amount of values that we actually have would just be your total frequency. If you added up the frequency, you'd find out how much that is. Now, the truth is, you don't have to add up the frequency. They gave you a cumulative frequency. So we know how many people they are. And they already told us 32 learners. So that's just another way of seeing that the cumulative frequency, that last value, it will tell you how much people that they are. That would be your N. That would be your number of values. So we're going to take that and I'm going to say this is equal to 32 plus 1 divided by 2. Okay, which is really 33 over 2. And 33 over 2 is 16.5. Okay, so what do we do with this number? Now, remember, this is just the median's position. Also remember that what we just did is we took this, okay, from N. N is the number of values. And that was really the total frequency. So this 16.5 is what we're going to look at in that cumulative frequency column, okay, in that, not really in the column, but on that y-axis. We're going to go to the cumulative frequency and we're going to look for 16.5 on there. It's kind of like saying we know that the median is a half of our data. Okay, I know this is the formula that we really accept, but if I was looking at it like this, it's a half of the data, right? We know that the total amount of values or the data values that we have, okay, the total amount of students that there were was 32. So we're really just finding kind of like a half of the 32. Okay, so the answer that it gives us is a cumulative frequency value, since we said a half of that, and that was from the cumulative frequency. Okay, so this 16.5, we're going to go to the y-axis and look for 16.5 here. Then, so here's 16, so 16.5, this is 15, it's right in the middle. 16.5 is right, this is 17. So 16.5 is in between here. And we're going to keep going to the ogive, sorry, it's actually not an ogive. So an ogive, we go to the ogive, and when we touch the ogive, we're going to go down and see where exactly this hits. So it's round about here, okay? Okay, so let's just see where exactly that is. Since this is 40, let me see what it's counting in. It's like 2, 4, 6, 8, 10. It's counting in twos. So 42, 44, 46. So it's like 46.5, round about there. Okay, so if they ask, where they ask for the median, right, of the data, that median is 46.5 marks, because remember, the X values are in terms of marks in this case. So that's how we find that, okay? Just make sure you use the formula, finally get that, divided by 2, and then you're going to just go onto the y-axis, hit the ogive, and then go down to the x-axis. Okay, so that is our answer. Moving on to the next question. Okay, but let me just be honest. You see this formula, I will not say it is correct for this particular situation. The thing is, you always have to look at what your frequency is, the total frequency. The total frequency was 32. 32 is an even number. The thing is, this formula was created especially because of single data. When the data is single and you see that the frequency is an odd number, we usually use this formula. So the formula I would actually use to calculate this, you can still do that. I mean, there are many past papers that you would actually see would still do that. I would have actually said n divided by 2, right? And here's the logic behind this. I'm trying to find a half of my data set. I want the middle of my data. So I'm going to take the entire data and cut it into 2, divide by 2. Okay, so that's really 32 divided by 2, which would give us 16. Okay, so that is the position. So I know now that on the y-axis, I have to go to where 16 is and then line that to the ogive. So that's what I'm going to do here. I actually prefer this, especially for the ogive. The only time I try to use that formula is in the case of single data. Because in the single data, if your frequency is an odd number and you just divide it by 2, it doesn't actually give you the middle. Okay. If you try this with different past papers, maybe, or even in your workbook, the exercises you would do in class, if you try it with single data, like single data is these ones that we did at first, these ones. Okay. If you try it with this and you just say n divided by 2, it's not going to work. Because here we knew we had 10 data, right? 10 pieces of value. And if you said 10 divided by 2, then, divided by 2, you'd get 5. And 5 is not really the middle of this data set. We know it's not the middle of the data set because if you try to find the data set by physically finding the middle, it's not going to be the fifth number. It's not the fifth number. See, if I cancel and cancel, second one's cancel, third one's cancel, fourth one cancels. You see that the middle is in between these two numbers. It's not the fifth number. That's why I said this formula, I only like to use this formula for single data, not too much for ogive, because with the ogive, it's not always going to be like that really. So you see that formula n plus 1 over 2, it works nicely with single data because these are physical values that you can actually see. Okay. But with these ones, these are grouped values. I don't actually know the actual marks of each learner. I know here that 5 people scored within 20 to 30, but I don't know if there's a learner who actually scored like 21 marks, for example, or 25 marks, for example. Okay. So with this one, because I can't really see the individual marks, using this formula will actually be fine here. Okay, so we can go ahead and find it. And so I'm going to go to 16 on the y-axis because I just found half of the data. I found half of the cumulative frequency, which was 16. And then I'm going to line this all the way to the ogive. And when I get to the ogive, I'm going to go down and see what number that I reach. Okay, that's the number. Let's just see where it is. Since these are counted in twos, that's 42, 44, 46. So that is 46. And I would actually trust that answer more. The reason I say I would trust that answer is because of that whole story I told you with the single data and the group data. Okay, that single data one, yeah, you can trust that formula n plus 1 over 2. That's good for that because this one would work. And the truth about this is it works whether your n, right, the number, the frequency number, that value, whether that is an odd number or whether it's an even number. In fact, I feel like it was developed because people started noticing that it doesn't work well for even numbers. You saw with the above single data, there were 10 values. When I said 10 divided by 2, it gave me 5. But I knew the fifth number was not the median. It was in the middle of the data. And so that's why that was developed. So if you said 10 plus 1 over 2, then it gives you 5.5. Then you're able to take the fifth and the sixth and then divide it by 2. Then you're able to find that middle. You see, that works very well with a single data, but I wouldn't really recommend using it for the ogive. But I would also say grade 11s, because your teachers mark your paper, rather follow the steps that your teacher said. But that is really, even in general, that is the widely accepted one for an ogive. Okay, so there, it is actually 46. So the median is 46 marks. Okay, so that is the answer I'm going to take, and I'm going to go for that. Okay, moving on to the next question. Okay, so that is that answer. Moving on to the next question, 2.4. The last question in question 2 says, from the cumulative frequency graph, determine the number of learners who obtained a mark of more than 55. Okay, more than 55. Let's go to the cumulative frequency and let's see this. Okay, so with this question, you have to be very, very careful. They didn't ask for the amount of students. They didn't say determine the number of learners who obtained a mark of 55 or lower. They said more than 55. And there's a reason I'm saying that. You see, if we go to the marks and we go find out where exactly 55 is here. So this is 52, 54, 55 is in between, right? So here, round about here. Okay. So since we know that's the middle, that is 55 itself. I'm trying to show you that if you went from 55, and I'm going to have to put this in a different color. Let's put it in blue. If we went from 55 and you just went up like this and went to the ogive, please note that you're not going to find the people who got more than 55 marks. The people that you're going to get here, and I'm just going to, it looks like it's supposed to hit this line. I think it's supposed to hit that line. It's probably just the way I drew the curve. Yeah, I'm just going to say it's hitting that line. Okay, so if you look at that, let's say this is it, right? 24. And about 24 learners. I want you to understand what this part means. When I went to 55 and I lined it up to the ogive, I got 24. This means that 24 learners scored either 55 marks or lower than 55 marks. Okay, so 55 or lower are these 24 learners because it's everybody here. You see? So 24 learners and everybody lower than that. So it's about 24 learners that scored either 55 or lower. We want to find the people who scored more than 55. So we're not looking within here anymore. We're looking here. Okay, so how much people scored 55 and above? Or more than 55, not really 55 and above, just over 55. How we would find that is like this. Because we want to find everybody who scored more than 55, we need to find out how many learners were there in total. There were 32 learners, okay? And do you see now at 32, the marks that line up with 32 is 90, meaning the highest or the total amount of marks was 90. It doesn't really mean the total marks was 90, like the test was out of 90. It could possibly just mean that nobody got maybe over 90. Everybody got like 90 and below. So that's why that's the last dot we have there. So if you want to find out the people who got more than 55, you're going to have to look at it like this. We're going to take the 90. We're looking at people within here from 55 all the way to 90. These are everybody who got more than 55 marks. So how many students would that be? Well, if you look at what cumulative frequency or how much marks is by 90, we have 32, meaning 32 learners were the total amount of learners who took the test. And we can actually see this clearly from here because we've already marked 34. 32 learners are the total amount of students who took the test. The people who got 55 marks or lower would be 24. That's everybody here. So the people who got 25 and higher, or really just more than 25, that would be everybody here. Okay. So you see, for this, you're going to have to go to what the highest amount was, right? The total of that. And you're going to go to the people who got 55 marks, and you're going to have to say 32 minus 24. That will tell you the people who got more than 55. Okay, so 32 minus 24, and we'll get our answer there, which is 8. Okay, so I'm just going to also put the calculation down there. So people got more than 55 is 32 minus 24, which is equal to 8. Those would be everybody who got above 55 marks, because the people who got 55 and below are 24, and the total amount of learners is 32. So subtract them, and that's the people who got more than 55. Okay, moving on to the next question. Okay, so now we're on question 3. Also, just please know that question 2 was worth 10 marks. So really try to score those marks. Remember, statistics is one of the simplest parts of this. Okay, I said 8, but let me just say 8 learners. Okay. Okay, so question 3. Question 3 says, in the diagram below, the points A, which is 0 and 7, B, which is 10 and 2, and C, which is 7 and negative 4, and D, of course, which is X and Y, they form a quadrilateral, A, B, C, D. Then they tell us that AB is parallel to CD. Okay, so there, these two lines are parallel with AC joined, okay? The angles of inclination of AC and BC are theta and alpha respectively. So there are those angles of inclination of those lines. Then the first question, we have to determine the length of AB and leave your answer in simplest third form. Okay, so let's go ahead and start with the first question. Okay, so to find the length of AB, I'm just going to write the coordinates down so I have them already. Remember, the coordinates of A is 0 and 7, and the coordinates of B is 10 and 2. And I put them in a top-down position because it's easier to work with it like this. So to find the distance formula is really just the square root of x2 minus x1. I know most people would say xb minus xa, and that's fine. Okay, given that you have a and b, you can say x of b minus x of a all squared plus the y value of b minus the y value of a all squared. So we're trying to just find the distance of AB. Okay, and this is going to be equal to, so I'm just going to put in these values now. What is the x value of b? It's 10. So 10 minus the x value of a, which is 0. That's why I put them in a top-down way. Squared plus the y value of b is 2 minus the y value of a, which is 7, all squared. And you can just put this onto the calculator and leave it as a third. Okay, when I substitute that, I get 5 square root 5. So there we go. That is the length of AB. Okay, moving on to the next question. The next question is asking for the gradient of AC. Okay, the gradient of AC. So let's look for AC. You see A and C, they have their coordinates. So to find the gradient, just use the gradient formula. The gradient formula is, the gradient is always going to be equal to y2 minus y1 over x2 minus x1. If you want to put it in terms of A and C, that's also fine. Okay, I've also put down their coordinates as well to just make this simpler. So we're saying y2 minus y1. So the second y value minus the first y value. So that's negative 4 minus 7 over 7 minus 0. Okay, and the gradient of AC is therefore going to be equal to, I'm just going to sub onto the calculator because it's just going to be quicker. And I get negative 11 over 7. So there we go, gradient of AC. Okay, you can also just check because the gradient is negative, AC should be a line that is decreasing, it's going down. So you read lines or graphs from the left to the right, and you can see moving from left to right, it is decreasing. Okay, so that's our gradient. Moving on to the next question. Then 3.3, we have to find the size of theta, which is the angle of inclination of AC. Okay, so theta's angle of inclination of AC. As you can see, it's going from the x-axis to the line. So to find this, I also want you to please notice a kind of angle that you have here. You have an obtuse angle, okay? When you have to find the angle of inclination of a line that is clearly a decreasing function, meaning its gradient is negative, this is how we find it. So we're going to use the formula that we always use to find angle of inclination, which is that tan of theta is always equal to your gradient. In this case, we're taking the gradient of AC. So tan of theta is going to be equal to our gradient, which is negative 11 over 7. Then, in order to solve for theta, we're going to have to take tan over, okay, the second function of tan. So we'll have theta is equal to the second function, shift tan on your calculator, of course, and we have negative 11 over 7. Now, first of all, before even adding what I'm supposed to add, I want to show you what happens when you do this. If you press shift and then tan to get the second function and you say negative 11 over 7, do you notice that this gives you a negative angle? Okay, but look at the angle we're looking for. The angle we're looking for is an obtuse angle. That's obtuse. It's not negative. So I want you to show you what it's actually measuring. It's measuring this angle over here. See, because it's also still going to AC, but it's just being measured the wrong way. We measure angles going like this way, anti-clockwise. But this is just measuring the angle clockwise, so that angle is negative, okay? So that's where that is coming from. Now, we don't want that angle. We want this angle. So in order to get that angle, you're going to have to do something. We're going to have to add 180 degrees to that number. So if you say plus 180 degrees, There, you see, it gives you your obtuse angle. So I'm going to just say plus 180, and they want to see that. Plus 180 degrees. And so theta, okay, the angle we're looking for is 122.47 degrees. And I don't remember them saying round off anyhow, so we're just rounding off to 2 decimal places. And that is the angle theta. Okay, moving on to the next question. Okay, and then the last question for this section, okay, on analytical geometry. No, there's another section still. But the last question for question 3 is actually, they're asking for the magnitude, or the size really, okay, of BCD, angle BCD. So let's mark out where angle BCD exactly is first of all. Look at the angle BCD, B to C to D. That's what they're asking for. BCD, like that. And remember, there was a cap or like that kind of thing, BCD, on C. So this is the focal angle. This is the angle we're focusing on. That's the angle we need to find the size of. Okay, so there are different ways of finding this angle, but I'm going to deal with this using this method that I use. So the method is, first of all, when I see that they're asking for a specific angle, I find the point where the angle has been created. And in this case, you see that this angle was created because of the line BC and the line DC intersected. So this is the points that they were created right there. What I do at that point is, first of all, I draw an imaginary x-axis. So this is usually going to be a dotted line, and I'll make it dotted right now. So I'm going to have a dotted line passing through there. Okay, this just helps me to be able to see this angle better. Okay, now that we have this imaginary x-axis, because it actually is an x-axis, what I'm going to do is I'm going to find out how this angle was created. How is this angle created? Well, notice that if I find the angle of inclination, okay, so we're working with angle of inclination. If we are working with angle of inclination, it's always measured from the x-axis to the actual angle, okay? If you find the angle of inclination from this x-axis, the one that I drew, to this angle, right? If you find that angle of inclination and then you subtract it by the angle that we're going to find from going from the x-axis again to this line. Do you notice that if you say this big angle minus this angle, you'll be left with this part, which is the blue angle, which is angle BCD. That's what they're looking for. Okay, so this big angle, okay, all the way to this line, CD, minus this angle, you'll be left with this angle. Another way of seeing this is, let me just put it like this. So you have some sort of angle that is like this. You have your x-axis and you have these two lines. We're trying to find this angle. So I'm just saying, if you take this entire angle and then you remove this part from it, this one, gone. Do you see that you're left with this angle? Okay. So that's how we're going to find it, using the angle of inclination. If we find the angle of inclination of the line CD, and I'm going to call that theta of CD, so this entire one, which is in red, and you minus it by the angle of inclination of the line from here all the way to here, BC, minus it by the angle of inclination of BC, you will be left with this blue angle, which is that angle BCD. So that's how I'm going to find that, by finding the angle of inclinations of these two angles. Now, let's stop and think about that carefully, because they did ask us, remember in analytical geometry, the previous question usually has a lot to do with the next question. Okay, but if I'm being honest, in this one, I'm not really seeing that. I'm not seeing how this angle over here helps us with it. It probably will in another sense, but I'm not really, because this is just going from the x-axis to AC. If I have to measure from the x-axis to AC, it's just going to be this. Okay, so not really helpful in this case. So this is how I'm going to find this. Angle BCD is equal to this. Let me go ahead and write that down. Okay, so now that we have this down, we just have to find the angle of inclination of CD and the angle of inclination of BC. That's all we have to find, and we will find BCD. So let's start off with the angle of inclination of CD. Okay, so if you look at this, how do we find the angle of inclination of CD? Well, unfortunately, we do not have D. However, they did tell us something about parallel lines. They told us that CD or DC is parallel to AB. So, in order to find the angle of inclination, you need the gradient first. So that means, even though we don't have this, okay, we can actually still find the gradient of this line. That's all we need, the gradient, by finding the gradient of AB. So let's actually try and find the gradient of AB first. So the gradient of AB would be found by saying, you can write the formula down. I'm just going to say y2 minus y1, so 2 minus 7 over x2 minus x1, so 10 minus 0. And let's see what I get. So 2 minus 7 is negative 5 and 10 minus 0 is 10. So negative 5 over 10 is negative a half. So that's what we have. The gradient is negative a half. And now that we know the gradient, this means that the gradient of AB is exactly the same thing as the gradient of CD, because those two lines are parallel. So the gradient of CD is also negative a half. Now I can finally find theta of CD. So I can say that tan of theta is equal to the gradient. And I'm saying the tan of theta of CD, and I'm just going to keep writing that in red so I remember what it is equal to negative a half. Then take tan over, and so theta of CD is equal to shift tan, second function of tan of negative a half. And let's see what we get. But the thing about this is you need to see the angle that you have there. You see theta of CD is the angle of inclination of CD. As you can see, this angle of inclination of CD, that big red angle, is an obtuse angle. So because it's obtuse, you need to add 180 degrees to that, again, like in the previous question. Okay, 180 degrees. And let's see what we get here. And I get as my answer of theta of CD as 153.434. Now, the thing is, I would not round off. It can't be a fraction or a third or anything like that, but I wouldn't round off. So really, you see, this calculation is going to be very important. If you don't want to, if you want to stay safe with this, then at least keep 4 decimals. You can just keep it as 4 decimals, and this should be enough to not tamper with your answer. Okay, so we just found theta of CD. That's done. Now we need to find theta of BC. So how do we find this theta of BC? Okay, so to find theta of BC, you just need the gradient of BC. Let's look at what we have here. The gradient of BC. Didn't we find the gradient of BC? What did they ask for when they asked for the gradient? Oh, they asked for AC. They didn't ask for BC. The steps I'm taking feels longer, so I will still try to look at shorter methods that I could have used to find this. So BC, I would also have to find the gradient of B and C. Okay, so these are the coordinates that we have. So again, the gradient of BC now is going to be y2 minus y1. So that's negative 4 minus 2. And then over 7 minus 10. Negative 4 minus 2 is negative 6. Over 7 minus 10 is negative 3. And so negative 6 divided by negative 3 is positive 2. Okay, so that's the gradient of BC. So now we can find the angle of inclination of BC. And as you can see, you see BC, that's an increasing function. That's why the gradient is positive. So there won't be a need to add 180 degrees here. This is an acute angle. You don't have to do that. We do that for these obtuse angles, because the obtuse angles, their lines, the gradients are negative. And so you're going to have to add 180 degrees so that you're not measuring that anti-clockwise angle, that clockwise angle, I mean. Okay, so let's go ahead and find that. So again, I'm just going to say tan theta is equal to the gradient, but I'm just trying to find the gradient of BC, the angle, okay? And then that is equal to 2. So that's the gradient that we got. Then theta of BC is equal to shift tan of 2. And let's go ahead and see what we get. Shift tan of 2. And this is the answer we get. We get 63.43. And I'm just going to say like that. Still the same decimal, so they're really just going to cancel with each other. Okay, so to find the actual answer, remember the answer we're looking for is this. To find this, we have to say theta of CD minus theta of BC. So BCD is equal to the theta of CD, which is 153.4349, minus theta of BC, which is 63.4349. Same decimal, so this one wouldn't even matter if you had rounded off, okay? Because they're just going to cancel at the end of the day. So BCD is equal to, and you can keep it at 4 decimals. In this case, it would work out. It will not tamper with the answer much. And there we go. We get 90 degrees. Okay, so it's very interesting that that is equal to 90 degrees. Means there's a whole lot of other questions they can probably ask you. So let's go ahead and see. So that is our angle. Now, I don't know if there are other ways. There are probably other ways to find it. Let me just look at it. But for the sake of the length of this video, I don't want it to be that long. Let me just see. Okay, the only other way I am seeing when I'm looking at this is you could have assumed or thought that maybe BC is actually perpendicular to DC. But you wouldn't just say, okay, they are perpendicular. You would have had to find out whether they were perpendicular or not. So this is how I would do this. So this is the second method of finding that angle. This one I did was quite long. I don't even think they would want you to do that. But that's the method I'm used to dealing with because that helps me to see the angles better. So let's say we were saying that those lines could have been perpendicular. So I'm saying perpendicular lines in this case. Okay, so if we were saying, supposing these two are perpendicular, let's find out whether they really are. We would have only tried to look for the gradient of BC and the gradient of DC. And this is the reason why. You see, with perpendicular lines, if you take the gradients of perpendicular lines, so if you take the gradient of BC and we multiplied it by the gradient of CD, and they give you -1, then it means that those two lines are perpendicular. And so if these two lines are perpendicular, it means that the angle here is a 90-degree angle. So this is how we could have also done this. We'll find the gradient of BC, find the gradient of CD, multiply them, and see, do they give us -1? And let's go ahead and do that. Okay, so I'm not going to go find the gradients because I already did that before. So finding the gradient of BC, we know that the gradient of BC was 2, right? Gradient of BC is 2. BC is 2. So we found that already. And the gradient of CD, we have a gradient of CD as -1/2. Okay, gradient of CD. As you can see, gradient of CD is -1/2. If you had said the gradient of BC times the gradient of CD, you would see that 2 times -1/2, is actually going to give you -1. Okay, -1. And therefore, it would mean that the BC is actually perpendicular to CD. Because they're perpendicular, that angle in between, okay, because these two lines are perpendicular, the angle BCD would be a 90-degree angle. And so we could already conclude and tell them that that means that angle BCD is equal to 90 degrees. And I think this is what they wanted you guys to do. Okay, so that's just another way now to look at it. So always keep your eye out for possibility of perpendicular angles. Okay, perpendicular lines, sorry. So there we go. Now we can move on to the next question. This was the last question for question 3. That's 12 marks. Then we move on to question 4, which is still on analytical geometry. Okay, so now we're on question 4, and question 4 says, consider triangle KLN drawn below. KL has the equation y is equal to 5x plus 9, so that's KL. And while KN has the equation 5y plus x minus 19 is equal to 0. So that's that equation. Also notice that it hasn't been put in standard form. You can go ahead, of course, and put it in standard form. Okay, so the first question in 4.1 says, show that the coordinates of K are -1 and 4. So basically, they just want you to find the coordinates of K. So let's think about what they have given us to actually find these coordinates. First of all, they told us that the line KL, it told us that this line, its equation is y is equal to 5x plus 9. That's the equation of KL, okay? And then they also told us that equation as well. If you're trying to find k, do you notice that this is the point of intersection of the line KL and the line KN? So we could just take the equations and equate them. That's one way of doing this. So I'll show you two ways of doing this. You could also just put that in standard form and then, find the points of intersection by equating the equations. The second way is to just treat it like a simultaneous equation, because that's really what simultaneous equations are. They are two graphs intersecting and you're finding their points of intersection. Okay, so let me start off with a quicker method. So with this quicker method, remember that the equation of KL, right? That is that y is equal to 5x plus 9. And then the equation of Kn, I'll leave it as it is. I'm not going to put it in standard form in this one. The equation of Kn is 5y plus x minus 19. So 5y plus x minus 19 is equal to 0. Here's why I say this. I'm going to look at these two equations and I'm going to treat them as these are two equations we've been given, and we're going to solve for x and y simultaneously. Okay, so as you can see, you can take the first equation, I can call that equation 1. I can take the second equation, and because the first equation already has a subject y, I can substitute the first equation inside the second equation. So we're just really substituting equation 1 into equation 2. And we'll be able to find the answer like this. So equation 2 says 5y. So whenever I see y, I'll replace it with this, with 5x plus 9. So 5 bracket 5x plus 9 plus x, then minus 19 is equal to 0. Okay, let's solve for x now. Okay, so you see all we're doing here is we're just taking this equation and we're substituting it inside that equation. It's the same thing as equating the equations, like putting this in standard form really. Okay, so that's going to give us 25x, and then 5 times 9, that is positive 45, then plus x minus 19 is equal to 0. And now, as you can see, this is a linear equation. So we're just going to leave the x's on one side and take all the numbers over. So 25x plus x is 26x, which is equal to, so I'm taking this 19 over and it becomes a positive 19. I'm also taking the 45 from the left to the right, and that becomes a negative 45. Okay, so we have 26x is equal to 19 minus 45. Let's see what that is. Okay, that's actually negative 26. And then we will divide both sides by 26. And we get that x is finally just equal to negative 1. Okay, now you can treat this as your equation 3. We've solved for x. Now we need to solve for y. So in order to solve for y, you can substitute equation 3 into equation 1. So that's what I'm going to do. I'm going to sub equation 3 into equation 1. And let's see how we get that. So y is equal to, and we have 5x plus 9. So this is 5 bracket negative 1 plus 9. And 5 times negative 1 is negative 5 plus 9 is like saying positive 9 minus 5, which is 4. Okay, you can also just put that on a calculator. So there we go. That is what we have as x and y. So it means that the coordinates of k is negative 1 and 4, just like they asked for it. Okay, so I would actually recommend that that's actually the better way to do it, because if you have to put this in standard form first, you're wasting more time, and it's only for 3 marks. Okay, so you can solve for it like that. If you like, you can put that in standard form, meaning put it in the form of y is equal to mx plus c. Okay, you would leave 5y, then you would take these over, so you would have positive x, no, negative x, because it's positive on this side, negative x, and then you will have a positive 19. Then you have to divide both sides by 5, so y is equal to, and then you would have, see it like this, okay? This is negative x over 5, but there's actually an invisible 1 here. So it's the same thing as saying negative 1 over 5, so negative 1 over 5, x plus 19 over 5. Okay, so you could do that and then, of course, equate the two equations and solve for x. It will still be the same thing. It just takes more work here. Okay, so that's how I would have solved it, just like this here. Moving on to the next question. Then the next question, 4.2, says, show that KL is perpendicular to KN. How do we show that two lines are perpendicular? If the gradient of the one line multiplied by the gradient of the second line give you -1, then the lines are perpendicular. So we just have to show them that the gradient of KL multiplied by the gradient of KN actually give us -1. That's all we need to show them. Okay, let's go ahead and find these gradients then. The gradient of KL. So where's our line of KL? This is KL. This is the equation. Remember, it's in the form of y is equal to mx plus c. So what's the gradient of this line? It's 5, okay? So the gradient of KL is equal to 5. And now let's look for the gradient of KN. The line of KN, its equation was this. So KN has the equation of this. You're just going to have to put it in standard form like I did previously. So that's probably why you shouldn't put it in standard form in the previous question, because that's, what you're going to do here. So Kn, let's go ahead and put that. So 5y plus x minus 19. So let's go 5y plus x minus 19 equals to 0. So let's put it in standard form first so we can see the gradient. I'm leaving 5y here is equal to, I'm taking the x over, it becomes -x. Taking the -19 over becomes +19. Then I divide both sides by 5. And so y is equal to, so we have, okay, and then remember, just like I said there's a -1 in the middle here, okay, in front of x. It's actually, there's a -1. And so it's like -1x divided by 5. And let me actually just kind of show you in sort of like a slow motion on how this actually works. You see, you have -1x over 5. And no, yeah, this is the numerator. But the thing about x is that you can kind of like separate it. And this is the reason you can do that, because the x is sitting next to the -1 over 5. It means that it's multiplying by it. And so the denominator of x is actually going to be 1. That's the placeholder that we have there. So if you had to have put this back together, you see -1 times x is -x. 5 times 1 is 5. So you see, it's the same thing as writing it as -1 over 5x. Okay, you're going to do that a lot in grade 12 because of something called inverse functions. Okay, so if we have this, it's -1 over 5x, and then +19 divided by 5 is just +19 over 5. So now we know the gradient of Kn. So I'm going to say, therefore, the gradient of Kn is equal to -1 over 5. And then I just have to show them that when we multiply them, they actually do give you -1. So I say, therefore, the gradient of KL multiplied by the gradient of Kn, and that is going to be the 5, of course, multiplied by the -1 over 5. And this will give you -1. You can also check that on the calculator. Because their gradients multiplied, or the product of their gradients, is -1, this would mean that the lines are perpendicular. So therefore, KL truly is perpendicular to KN. There we go. Okay, and that was for 3 marks. Moving on to the next question. Okay, question 4.3. Hence or otherwise determine the area of triangle KLN. So, area of the triangle. Well, we know that these two lines are perpendicular. So let's actually mark that out. KL is perpendicular to KN. So we have a 90-degree angle here. This is a right angle triangle. When they ask you to find the area of a right angle triangle, this is a good thing because it's really not that bad. You can find the area of a right angle triangle by using the formula of the area of a triangle, which looks like this. The area of a triangle is equal to a half multiplied by the base of the triangle multiplied by the perpendicular height of the triangle. Okay, so we just have to make sure that we actually have all of these things. We have to make sure that we have a base and we have a perpendicular height. The fact that these are already perpendicular, we have a perpendicular height. Okay, so what we can do is we can take Kn as the base. Remember, we have the coordinates of K now. We can take this one as the base. And we can take that as the height. You see, the height must be perpendicular to the base. So there, all we need is, we only need the length of the base, which is Kn, and we need the length of the height, which is KL. That's all we need. And we can find the area. Okay, so let's go ahead and start finding those. So remember the coordinates of K, we already put that down. It's -1 and 4. So that is -1 and 4. We can just find the length of KL first of all using the distance formula. So let me put down those coordinates. So K and L. Okay, so we're finding the distance of KL. So the distance formula is the square root of x2 minus x1. If you like, you can call it in terms of the letters. Like you can say xk minus xl. Even if you said xl minus xk, it doesn't matter. As long as you stay consistent with the y's as well, you also have to say yl minus yk, okay? But I'm just going to use the x2 and x1. So x2 minus x1 all squared plus y2 minus y1 all squared. Also, if you put it in the form of first, you put the y2 minus y1 all squared, then the x2 minus x1, it doesn't matter because you see that they've just been added either ways. Okay, so the distance of KL is going to be equal to, and let's just go ahead and substitute that into this formula. So that's going to be, what is x2? I can just choose anyone as x2 really. So I'll just go with these ones being x2. So -2 minus -1. So please remember, -2 minus the -1. You're going to need brackets here. And so if that multiplies in, that becomes -2 plus 1. Okay? So I'm going to write that like that. -2 plus 1 all squared. And then we have plus, so those are the x values. Then we have -1 minus 4. Now that doesn't become a plus because it's just -4. So -1 minus 4 all squared. You can substitute that into your calculator and see what you get. Okay, and my answer is the square root of 26. I'm going to take it like that. I'm not going to round off because this is not my final answer. This is just the length of my base. Okay, so I got KL, the distance of KL. After finding the distance of KL, you have to find now the height. Oh, KL is the height, sorry. We have to find the base now, so KN. So I'm just going to put the coordinates of K and N. Okay, so finding the distance, I'm not even going to put down the formula. I'm just going to say, I'm finding the distance of Kn. You know, you can also just say Kn. Okay. And it's equal to the square root of, and I'm saying x2 minus x1, which is 4 minus -1. So that's 4 minus -1, which will multiply in, of course, and become 4 plus 1. So that's 4 plus 1 all squared. And then we're going to have plus, and then of course with the y's as well. So y2 minus y1 all squared. That's going to be 3 minus 4. So 3 minus 4 all squared. And let me see what that gets us. Okay, and surprisingly, we also get root 26. So the square root of 26. So we have an isosceles triangle. Okay, so now that we also have the base of the triangle, we can find the area of it. Okay, so just remember the area of the triangle they're asking for. Let me just name the triangle. The triangle's name is triangle KNL, sorry. So triangle K and KNL is equal to a half multiplied by the base of the triangle, which we now know is the square root of 26, multiplied by the height of the triangle, which is also the square root of 26. Okay, so what's going to happen here is, I don't think we need a calculator for this. You see, we have a half. So, and this is being multiplied by two things that are the exact same thing, and they are surds. You see, just like if you have x times x, it gives you x squared. If you have 2 times 2, technically it also gives you 2 squared, which is 4. But then if you have now the square root of 26 times the square root of 26, it's going to give you the square root of 26 all squared. But the thing about the square root and the squared is that they're the inverse of each other. So they would cancel each other. They will simplify with each other. And so you'll be left with just 26. Okay, so that is multiplied by 26. So a half times 26 is just really a half of 26, which is 13. So there, that is our answer, 13 units squared, because it's in area. It's area. Okay, that is the area of that triangle. And we've also now discovered that this triangle is actually an isosceles triangle. So we can see now that this is equal to that. Okay, moving on to the next question. Okay, 4.4 says determine the equation of the perpendicular bisector of Ln. We need the equation of the perpendicular bisector of Ln. Okay, let's go ahead and look at what that looks like. The perpendicular bisector of Ln. So it's a line that is bisecting this line Ln, okay, and forms a perpendicular line. It's basically perpendicular. That line is going to be perpendicular to this. Okay, so the good thing about this is now that we know this is an isosceles triangle, the perpendicular bisector is going to work like this, okay? Because this side is exactly equal to this side, right? The line is going like this, and it is going to be perpendicular to this line. Now, there's another word that you need to take into account. That word bisector. Okay, when something bisects another thing, it's not necessarily just cutting it. That's not all it's doing to it. It's specifically cutting the line into two equal parts. It's cutting it in half. That's what it means to bisect, okay? It's very different from the word intersect. Intersect just means to cut into. Bisect means to cut into half. So what we know about this perpendicular bisector is that it's going to cut the line Ln into two equal parts. Let me just put a different line for that. Okay, so it means that in order to find the equation of this line, see, we need this equation. We've got the coordinate k, that's great. But we'd need another coordinate, like this one over here, right? We need this coordinate in order to find the equation of this perpendicular bisector. Now that we know that it bisects this line perpendicularly, okay, it bisects the line, just emphasis on the fact that it cuts it in half, we would know that this point here would be the midpoint of the line of this Ln, okay? Since this is equal to this, here's your midpoint. This is the midpoint of Ln. So I'm just going to call that M as midpoint. Okay, so what we have to first do to find the equation of this line, if you can find the midpoint of the line, then you have one coordinate here, you have k as a coordinate, and you have m, you can find the equation of that line. Okay, so there we go. Okay, so let's go ahead and start finding the midpoint. So we need to find the midpoint of Ln. Okay, and I've put down the coordinates on the side just so that this will just be easier for us. So midpoint of Ln, remember that the midpoint formula says we have x1 plus x2 over 2 and y1 plus y2 over 2. I know you can't say it's equal to. I personally don't like saying it's equal to because it's a point. Like if I said A is 1 and 2, I would just say it's 1 and 2. I wouldn't say equal to. So it's just a habit, but it's not that it's going to be wrong either ways. Okay, so the midpoint now of Ln would be, and so I'm going to just say x2, which is negative 2. So negative 2 plus x1, which is positive 4 over 2. And then we have negative 1 plus 3 over 2. Okay, x1 and x2, y1 and y2. And so finally, we know that the midpoint of Ln is just what is negative 2 plus 4 over 2. It's the same thing as saying positive 4 minus 2, which is 2. Divided by 2 is 1. And then negative 1 plus 3 is the same as saying positive 3 minus 1, which is 2. Divided by 2 is 1. Okay, so the midpoint is 1 and 1. Now that we know that point, we can actually find the equation of that line. We know the midpoint as 1 and 1. Yeah, I drew that thing so way off. It's not even supposed to be there. It's probably like somewhere here because you have that, and then it's probably like, Okay, anyway, they always tell you it's not drawn to scale, so you can expect things like this to happen. This doesn't make sense for that to be 1 and 1, but yeah, that's what the coordinates are. Okay, so we can now use this k and we can use the midpoint to find the equation of the line. So I'm using k and m, and I'm going to find the equation of the straight line. Okay, so to find the equation of this line, the equation of a straight line is, well, we first need the gradient. You know that it's y is equal to mx plus c. I'm actually going to use a different formula here. I'll show you another formula that you can use that will just help you to find the equation quicker, because you don't have to find c then substitute it back in. So first you need the gradient, okay? We need the gradient of k m. Remember, capital M is for midpoint, small m is for gradient, is equal to, so that's y2 minus y1. So I'm just going to actually use it. I'm not going to put the formula down. I don't think that's necessary. So y2 minus y1, so I can see it as 1 minus 4 over x2 minus x1. And then we're going to say 1 minus negative 1. Remember, 1 minus negative 1 is going to end up giving 1 plus 1. Okay, so that's 1 plus 1. Okay, so the gradient of km is 1 minus 4 is negative 3. And then 1 plus 1 is 2. So that's our gradient, negative 3 over 2. And now we just have to find the actual equation. So look at the formula I'm going to use. You can use y is equal to mx plus c as the equation of a straight line. This is your gradient and that's your y-intercept. But I'm going to use this equation. It's y minus y1 is equal to m bracket x minus x1. Okay, and here I want you to see that this y1 and this x1, they stand for 1 point. You're just going to take one of the points out of these 2 points and substitute it along with the gradient, of course. I'll choose the easy point. I'll choose m. So I'm saying y minus y1 is 1 is equal to, our gradient is negative 3 over 2 bracket x minus x1, which is 1. Okay, and so we have, this is why I say this is an easier one. I don't have to find the y-intercept. I just have to simplify this. So what I'm going to do here, and I'm going to just start here so you can see what happens. I'll multiply the negative 3 over 2 by the x, and I get negative 3 over 2x. Then I'll multiply the negative 3 over 2 by the negative 1, and that gives me positive 3 over 2. Then on this side, I'm going to leave y here, and I will take the negative 1 over. Now it becomes a positive 1. So this is now y is equal to negative 3 over 2x. And we've got this. Now, how do we add this? You can just add it on the calculator, but I'll do it here instead. So the 1, I'm going to call that 2 over 2 so that the denominators are the same. So it's the same as saying 3 plus 2 is 5. So positive 5 over 2. You can use a calculator. It will still work out. Okay, so that's how that is added up. Okay, and there, that is the equation of the perpendicular bisector of that line LN. Okay, moving on to the next question. Okay, question 4.5 says, if LN and P, which is 7 and y, are collinear, find y. So they are collinear. When lines are collinear, let's actually take them in the order. They're saying Ln and P. Remember that Ln is this line that we have here. Ln, right? That's negative 2 and negative 1 and 4 and 3. Let me put that down first. So this is Ln, right? They're saying that if Ln and P are collinear, you have to find y. So I'm putting down Ln and P. Since they're collinear, just means that they are on the same line. So let's say I extend this and I just put P, right? Now to find y, since P is 7 and y, we have to use the fact that they are collinear in order to solve for y. You see, if points are collinear and they lie on the same line, it means that the gradient is supposed to be consistent as well. Okay, so look at what we can say. We can say that means that the gradient of Ln should be exactly the same as the gradient of NP. So just remember, you can say that you could also look for it as the gradient of, for example, LP, right? Like I said before, should be equal to the gradient of NP. Even if you say the gradient of LP should be equal to the gradient of LN, it will still work. Gradient of LN. Okay, because they're all on the same line, LP to LN. You're just finding the gradient within these points. Okay, so I'm just going to go with this. So this means that the gradient of Ln, L to N, is y2 minus y1, right? So let's just be careful here. Y2 is 3 minus Y1 is negative 1. So that is 3 minus negative 1, which really just becomes a 3 plus 1, over x2 minus x1, which is the 4 minus negative 2, which is 4 plus 2. And this, of course, will be equal to the gradient of NP. NP, again, y2 minus y1. That's going to be your y. So we've got the y minus the 3. So y minus 3. And then this is over x2 minus x1, which is going to be the 7 minus the 4. So 7 minus 4. Okay, so we just have to solve for y in this equation that has been formed. So this means that we have 4 over, and that becomes a 6, is equal to y minus 3 over 7 minus 4. And then we're saying, okay, so why did I say 7 minus 4? That's just 7 minus 4 is 3. Okay, so now we can just solve for y. You see, if you're trying to solve for y is here. To get closer to the y, the 3 as a denominator is stopping us. So in order to get rid of a 3, right? Because this is being divided by 3. To get rid of that 3, you need to multiply by 3. But what you do on the one side, you need to do on the other side. So also multiply by 3 here. So this is what we're going to have. I could simplify this. 4 over 6 is really just going to be, if you simplify it even on the calculator, it's going to give you 2 over 3, because I can see there's a common factor of 2 throughout. 4 divided by 2 is 2. 6 divided by 2 is 3. So there, times 3, of course. And we'll sort that out. So here, the 3 cancels, and we have y minus 3. And here, you have 3 multiplied by 2 over 3. Even if you put that on the calculator, you'll see that the 3's will cancel diagonally, and you'll be left with just 2 here. So 2 is equal to y minus 3. If you take this negative 3 over, that is 2 plus 3, which is y. And so therefore, y is equal to 5. And there we go. So that is the value of y. Moving on to the next question. Okay, question 4.6 says, determine the coordinate of Q if KLQN is a parallelogram. Okay, we want to find the coordinates of Q. This is a parallelogram. Something I'm already noticing is this is only worth 2 marks. So it means there's not a lot of steps. Let's go ahead and look at our diagram and see KLQN. KLQN. So our diagram looks like this. I'm looking at KLQ. So Q somewhere here, right? And then N. So they kind of like connect like that, like that. I know that looks like a rectangle, but just imagine it's a parallelogram. Okay, so what can we do here to find this coordinate if the shape is a parallelogram? But it must not be a complicated process. So the minute I thought of parallelogram, so I just want you to always see the thought process that goes into it. It's not that we just look at a question and like, oh, okay, this is the answer. You think about it really. So I'm looking at this and I'm like, I would have liked to use the fact that in a parallelogram, opposite sides are parallel, but that will not work out. And I know that because when 2 lines are parallel, the gradients are equal. Similar to collinear points. When points are collinear, their gradients are also equal. Okay, their gradients must be consistent. Now you see the situation with collinear. You can only find a missing coordinate, just like one y value or one x value, when you're using the fact that the lines are parallel, okay, or the gradients are equal. When you're using equal gradients, you can only use it in this type of situation just when one thing is missing. The reason I can't use the fact that these 2 lines are parallel is because to find Q, it has an x and a y value. You see, not one thing is missing, 2 things, 2 coordinates are missing. I need to find the x, not coordinates, 2 values are missing. I need to find the x and the y value, and then I'll be able to actually find what this point is. So I can't even use the fact that the lines are parallel. That's not a good idea. It's not going to work for this. So what I'm going to think about is, what do I know about a parallelogram? Well, a parallelogram, something that we know about this is, it has diagonals. There's something that diagonals do. The diagonals of a parallelogram bisect each other. Okay, so what else do we know about a parallelogram? A parallelogram, the thing about a parallelogram is that the diagonals of a parallelogram, they do something to each other. They bisect each other. Remember the word bisect, right? It means to cut in half. So it means that this line, it cuts this shorter line into half. Likewise, the shorter line is also cutting the longer line into half. So there's one thing that we need to know from this, okay, we need to get from this. It would mean that the midpoint of the line, for example, let's say this is called A, B, C, and D, right? The midpoint of BC will be the exact same thing as the midpoint of AC. They have the same midpoint. So that's really what you can take from the diagonals bisect each other. It's that they have the same midpoint. And I'm going to use that. And the reason why is because it looks perfect to use here. Do you notice here that we already have one diagonal in this parallelogram, right? This KLQN, right? That parallelogram. We have a diagonal, which is LN. Okay. So all we need to find now is the other diagonal, which should be KQ. We have a piece of it. We even have the midpoint of it. So in order to find Q, I'm just kind of like connecting that like that. Okay. So KQ, in order to find Q, we can use the fact that since this is the midpoint, if this is truly a parallelogram, then it would mean that the midpoint of KQ would be M. So I can use the midpoint formula here. I can say that I have the midpoint of this line KQ, and I just need to find one of the endpoints of the line. Okay, so this is how I'm going to find it. I'm going to just screenshot this and take this to the bottom so that we can also just follow it. So this is how I'm going to use it. I'm going to say that the midpoint, right? I'm trying to find the midpoint of the line KQ. So K to Q. So the coordinates of K, it's -1 and 4. And Q is X and Y because we don't know those coordinates yet. And I'm going to attempt to find it. So finding that midpoint, I'll say x1 plus x2, right? Which is going to be -1 plus x over 2. So x1 plus x2 over 2. And then y1 plus y2 over 2. So that's 4 plus y over 2. And now that I have this, I'm also going to remember that the thing is I actually do have the midpoint of KQ that I'm looking for. The midpoint of KQ is this, M, which is 1 and 1. I have that. So I'm saying the midpoint of KQ is 1 and 1. And this is how we find it. So I'll just use an equal to sign here. Okay. And I'm just going to rewrite this. This is really just, let me rewrite this as x minus 1 instead of -1 plus x. So x minus 1 over 2. And I can also just rewrite that as y plus 4 over 2. Okay. So here, this is finding basically one of the endpoints when you're already given the midpoint. Since this is the calculation to find, okay, this is the actual midpoint of KQ, and this is the calculation of finding the midpoint of KQ, then this would mean that their x value should be exactly the same. So I'm going to make this equal to this, and their y value should also be exactly the same because they stand for the same thing. Okay, KQ is the midpoint. Midpoint of KQ is 1 and 1. And this is the calculation to find the midpoint of KQ. So therefore, I'm going to say that the x value 1 is equal to this x value, x minus 1 over 2. And the y value of 1 is equal to this y value, y plus 4 over 2. And now I just have to solve for x and y. So here, you're trying to solve for x. X is on the numerator. You need to get rid of this 2 as a denominator. Because it's been divided by 2, to get rid of it, you multiply by 2 on both sides because it's an equation. 2 times 1 is 2 is equal to, this cancels out and we're left with x minus 1. Take the -1 over, that is 2 plus 1 is equal to x, and therefore x is equal to 3. Okay, same thing here. Got the 2 on the denominator, we're going to get rid of it by timesing both sides by 2. 2 times 1 is 2 is equal to, that cancels out, you're left with y plus 4. Take the 4 over, that's 2 minus 4 is equal to y. And therefore, y is equal to 2 minus 4 is -2. So there we go. Now we know the coordinates of Q if this is if this is a parallelogram. Okay, so I'm saying therefore it means that Q is 3 and negative 2. Okay, so that's how I'm going to use that since it is a parallelogram. Okay, moving on to the next question. Okay, 4.7 says we have explained with geometric reasons why KLQN is a square. So that thing that they told us to prove, okay, to find Q with, given that it's a parallelogram, they're actually saying this thing is a square, but we need to show them why it is a square. Now, I know you're like, but I thought they said it's a parallelogram. And I'll probably talk about this more when I deal with a video on analytical geometry, when I specifically speak about how to prove shapes. The thing about shapes is that most four-sided shapes, of course, the ones with two opposite sides being equal, you know, those ones, right? They're first of all a parallelogram before they are what they really are. Like a rectangle is first of all a parallelogram before it is a rectangle. A square is even first of all a parallelogram before it's a rectangle. So it's no surprise that they told us first of all, if it is a parallelogram, find the coordinates of Q. But now they're saying, okay, but show us why this thing is actually a square. And from when we were working on this thing, I could see that, no, this thing can't just be a parallelogram. It's a square. That's why it's very important that when you are finding the things they're asking you to find in your diagram, you keep filling them in. It's going to help you a lot. Here's why this thing is actually a square. Do you remember that when we found the distance of this line and the distance of that line, it was exactly the same. It was the square root of 26, I think, right? Both of them were exactly the same. And do you also realize that we found that KL was perpendicular to KN? So there's a 90-degree angle here. This cannot be a parallelogram. This is a square. Okay? So proving that to them, I'm just going to tell them these things. So you just need to remember how to prove that something is a square. You need to really work on how to prove shapes. These will be important for your last questions in analytical geometry. Okay, so let me mention it here so that it's not like I'm just taking this out of some random place and just saying, no, but look at this is equal to that, so this must be a square. No, let me show you that there's actually ways to prove certain shapes. And I'm just going to work on a square for this video so that it's not too long. So the first requirement to prove that something truly is a square, okay, is to prove that if you can prove that it's, first of all, a parallelogram, right? And a corner angle is equal to 90 degrees with a pair of adjacent sides being equal, then this thing is a square. Okay, that's the first requirement to prove something is a square. So what I'm saying is you prove it's a parallelogram. Technically, we've already done that because do you see that in the previous question they told us to determine the coordinates of Q if that shape is a parallelogram. So they've already proven that it's a parallelogram. They stated it was a parallelogram. So we're already considering the shape is already a parallelogram. Now to prove that it's actually a square. So you can see a square like a type of parallelogram. That's what I was trying to say. A rectangle is a type of parallelogram. A square is a type of parallelogram. A rhombus is also a type of parallelogram. So this one, you just have to prove that a corner angle, once it is a parallelogram, one corner angle is 90 degrees and a pair of adjacent sides are equal. And you saw that's actually the requirement we have up there. That's the one that we have there. The second situation that you can actually just use is this. If you can prove that this shape is actually a rhombus, if you can prove that the quadrilateral is a rhombus and there is a corner angle, okay, corner angle equal to 90 degrees, then the shape is a square. And then the third way to prove that something is a square is if you can again prove that the shape is a rhombus and show that the diagonals are equal. Okay, but from the marks that they gave us, here just 2 marks, I'm going to go with this one because this is the one that is quite clear here. Okay, see, corner angle 90, a pair of equal adjacent sides. So that's what I'm going to state for them. I'm going to state that. I only put this here just so that you guys can see that there are actually ways to prove certain shapes. And this is how to prove a square. Okay, so what I'm going to say in this one is I'm going to state those things that are equal. We know it's a parallelogram, first of all. So that's what I'm stating first. KLQN is a parallelogram. That's the first thing. Then I'm going to show them the sides that are equal, or the corner angle really. And I'll tell them that the angle LKN is 90 degrees. That was already proven. Okay. LKN is equal to 90 degrees. And what else? Now we have to mention the two sides, two adjacent sides that are equal. These two are equal. Remember, they were both equal to the square root of 26. So I can tell them that KL is actually equal to KN because they're both equal to 26. And KL equals KN. They're both equal to 26. And so therefore, this means that KLQN is a square because it meets the first requirement, or the first properties to prove that the shape is a square. Okay, it must first be a parallelogram, and if you can find a corner angle being equal to 90 degrees and two adjacent sides being equal, then it's a square. Okay, you can of course word that out. Corner angles 90 degrees, two adjacent sides are equal. Okay, so I just added more to that. KLQN is a square because it is a parallelogram with a corner angle equal to 90 degrees and a pair of adjacent sides being equal. Okay, so that is the end of question 4, and then we move on to question 5. Okay, now we're in question 5, and question 5 says 5.1, determine the value of the following without the use of a calculator. Okay, of course we can't really use a calculator here, so we just have to simplify this trigonometric expression. Okay, so just make sure you use the correct rules, use your reductions, and you'll be able to simplify this. Okay, for the sake of understanding, I'm just gonna put down the reduction diagram just so that we can also look at it and reduce where it needs to be. Okay, so we first have tan 180 degrees minus x. So we're just going to reduce this. You're going to go to wherever you see 180 minus x. So that's over here in sine's quadrant, and ask ourselves, is tan positive in this quadrant? No, sine is positive here. So this is going to become negative tan of, and we're reducing the angle now, x. Okay, and this has been multiplied by, and we have cos 360 degrees plus x. I want to explain that one quickly. You see, most people look at that and they kind of think, oh, that's that quadrant. No, it's not. It's not that quadrant. Cos 360 plus x. Whenever you see an angle, right, you have to check two things. There's two situations that can happen with these angles. They can either be negative or they can be over 360 degrees. Okay, so it's either angle is negative or it is over 360 degrees. If your angle is negative, for example, if you've been given something like sine negative 180 degrees plus theta, what you need to do is see that, oh, this angle as a whole will end up being negative because we see theta as an acute angle. You have negative 180 plus theta. The theta is not enough to make this angle positive. So ultimately, this entire thing will be negative. When your angles are negative, the solution is to add 360 degrees. Okay, so you're going to add 360 degrees to this. So think about it. If you add 360 degrees to that negative 180, it's going to give you 180 degrees. And so this is actually sine 180 degrees plus theta. Then you reduce that. 180 plus theta, that's tan's quadrant, so this is negative sine theta. Now, the other situation is where your angle is over 360 degrees. And if your angle is over 360 degrees, you kind of do the opposite. You're going to minus 360 degrees. Here's an example of over 360, an obvious example. If I said tan and I had something like 540 degrees minus theta, okay, theta is an acute angle. It's not enough to help this to become, less than 360. So because of this, this is already over 360. And I'll look at that and say, oh, okay, I just have to subtract 360 from this. So I'll take 540 minus 360 and I get tan, and you're going to get 180 minus theta. And so you reduce that. As you can see, that is sine's quadrant. Tan is negative, so negative tan theta. Now there's this situation where you have 360 plus theta. Look at that angle. Is that under 360 or is it over 360? That's over 360 because you have 360 and you're adding a theta to that. Theta is seen as an acute angle, angles that are less than 90 degrees. You're adding 360 degrees to this already. It's now over 360. The solution is to subtract 360 from this. Okay, so let's go to the above one and actually do this where we actually need that to be done. So we're going to look at the fact that we have cos 360 plus x. This is an angle over 360 minus 360 degrees from this. So your 360 and 360 would subtract and become 0. So you just be left with cos of x. Okay, that's how to simplify that one. Don't look at it and say, oh, cos is positive in this quadrant. That's not cos's quadrant. Okay, over, and then we have 2 cos of 90 degrees plus theta plus x, sorry. So that is a cofunction. That's a cofunction. So 90 plus x. Remember, please remember all your cofunctions. I'm just going to list them here. I do have a video on my channel as well where I explain cofunctions. It's actually explaining something else, but I speak about cofunctions there. I'm just going to write them down here so that you remember. Okay, so see this as a little revision. If you have sine 90 minus theta, it just gives you cos theta, positive cos theta. Cos 90 minus theta, it gives you positive sine theta. So always notice if it's sine, it's going to change the cos. It's cos, it's going to change the sine. Sine 90 plus theta is positive cos theta. And I want you to see that this is the only one that is actually a little different. Cos 90 plus theta becomes negative sine theta, and in that video I also do explain that a little bit in more detail. Okay, so that's what we have there. So you see that this is saying 2 times cos 90 plus x, so that's 2 times negative sine of x. That's what that is going to become, because we can see what the cofunction for cos 90 plus theta is. Okay, and so this is equal to, and we have, well, everything has been multiplied. So technically, the negative and the negative, I would actually say they just cancel, because you see, this is being multiplied by this. If you like, you could have said negative tan x times cos x over 2 times negative sine x is negative 2 sine x. And you see that the negative and the negative is gone. And now with the tan, you can change tan of x to sine x over cos x. And this has been multiplied by your cos x here. I could cos x. So cos x over, and we still have 2 sine of x. So let's look at what happens on the numerator. You see, this as a fraction is actually cos x over 1. If you look diagonally, because we are multiplying, cos x can cancel cos x. So on the numerator, you're just left with sine x over 1, which is just sine x, divided by 2 sine x. And so here, sine x would cancel with sine x. And what are we left with? On the numerator, there is a placeholder of 1. Okay, that's the coefficient of sine x. There's a 1 on the numerator. And on the denominator, we're left with 2. So the answer is a half. Okay, so that is that simplified. Sorry, I just keep doing this because this is a little revision as well for my grade 11s, also writing. So I'm just trying to remind everybody about all these rules that you just need to remember. Okay, moving on to the next question. Then the next question, 5.2, says, given the identity, you have to, maybe given this, you need to prove the identity above the above identity. So take the side that has more things to actually work with. The right hand side, not so much to work with. The left, we can work with. So I'll say left hand side equals, and I'll just rewrite all of that. Okay, so now let's simplify this identity. I want you to look at the numerator of this identity. Do you notice that on the numerator, how many terms do you have there? There are 1 and 2 terms. Here's the minus sign separating it. Plus and minus signs separate terms. Now, within these 2 terms, what do you notice is common? There's a sine x, sine theta, sorry, being common. Now, you see, where I resort to taking out a common factor is like this. If I look at the top and I see that these two things are being added or subtracted, and I say that I can't really add or subtract them because they're not like terms, then my next step is, okay, can I take out a common factor? Because the whole point is to simplify it. If you cannot actually subtract them, then take out a common factor so that you can simplify it in another way. So I'm going to take out a common factor. So let's say I take out sine of theta out as a common factor and I open a bracket. What are we left with? In the first term, okay, we're left with, if you just divide those, so you're left with 1. Okay, and then in the second term, if you divide that with that, you're left with sine, and sine is going to cancel, left with negative 2 cos theta. Now the denominator. Okay, that denominator looks very, very familiar. It looks like a trinomial. 2 cos squared theta plus cos theta minus 1. If this is complicated for you to see, what you can do is you can replace the cos theta with k. So let's rewrite that as the cos theta being k. So you can say 2k squared, okay, because cos theta squared, cos squared theta, and then we have plus, we have cos theta, so that's k, minus 1. You see? That's a trinomial. So let's factorize that trinomial first. So I will use a method called the cross method. You may have another method. And this is how this method I use works. I say 2k squared, right? I say what multiplied by what gives me 2k squared. That will be 2k times k. And then what times what gives me 1? That's 1 times 1. Now, I have to multiply this, and this is called the cross method because we're going to multiply across. I'm going to say 2k times k, which gives me 2k, and k times 1, which gives me k. And I'm going to look at this and see the fact that this is negative 1, right? So it means that either one of this needs to be negative. One of it has to be negative, one has to be positive for you to get negative 1 over here. But which one? Now, how I find out which one is, this is the reason I multiplied them out first. Which one here should be negative so that you can get a positive k in the middle? The k, that should be negative, right? Because 2k minus k would finally just give you positive k. So now I ask myself, because I made this negative, here, how did I form k so that I can give the negative to whichever number helped me find k, right? So how I found k was by saying k times 1. So I'm going to give the negative to this one. And then by default, this one takes a positive. So that is 2k times positive 1, giving you positive 2k. And that's how I'm able to factorize that. So look at my factors. My factors are 2k minus 1 and 2k plus 1. So remember, I just said 2k because sometimes you look at cos theta and it's like, that looks a bit complicated. That's why I called it k. Now I'm going to just put it here, but I'm going to replace k back with cos theta. So this is actually 2. I have k, that's cos theta, minus 1. Multiplied by k plus 1, that's cos theta plus 1. Okay, so that's factorized. And now we're looking at these. Look at the top and the bottom. It looks like something could have cancelled, but the issue here is, look at this. This should have been able to cancel with this. The problem is that this one is positive, this is negative. This is negative, this is positive. That's not a problem. All you have to do is take out a negative 1 as a common factor in here. So this is how we're going to do that. I am removing a negative 1 from this bracket. When I do that, it's going to come out, and I'm just going to put it in front of the sign. So I'm saying negative, and then I still have the sine theta. And now because I've removed a common factor of negative 1, it's going to change these. I took out a negative 1 from this positive 1. It's kind of like just saying negative 1. This is your common factor, right? The negative. So negative 1 times divided by, the negative is going to give you a negative 1. And then we have the negative 2 cos theta divided by the negative is going to give you a positive cos theta. So there, that is sorted out because I've removed the common factor. Over, and then now we have 2 cos theta minus 1 multiplied by cos theta plus 1. Okay, And now that we have this, these two can nicely cancel because there's no, terms. It's just one term on top and one term on the bottom. This one just happens to be negative. It's not like we have like a 5 there. Then it would be two terms. Okay, then this is equal to, on the numerator we have negative sine theta. On the denominator we have cos theta plus 1. And let's look at our right hand side. Exactly. Negative sine theta over cos theta plus 1. And so the left hand side truly is equal to the right hand side. Okay, left is equal to right. And so therefore we have proven the identity. Okay, moving on to the next question. Okay, question 5.2.2 says, for which values of theta will the identity be undefined? Okay, so looking at the identity, and I'll actually look at it from the original one, or at least from this point where it was factorized. Okay, so you have to look at the identity and ask yourself, first of all, how can a number become undefined? A number can only be undefined if, you have whatever variable on top and the denominator is equal to 0. So as long as the denominator is equal to 0, then it is undefined. Okay, so we're going to do the same things with this identity. If the denominator is equal to 0, your identity is going to be undefined, of course, if that's equal to 0. But the thing is that when we were simplifying this, factorizing it, you saw that we got it to this point, which has 2 cos theta minus 1 and cos theta plus 1. That's also showing here. So as you can see, if this is equal to 0, I don't have to say if this is equal to 0 or this is equal to 0, because please notice that this is this already. Okay, it's already there. So if I can show that this, okay, is equal to 0, I'm going to find out the values of theta for which it will be undefined. So I'm taking that denominator. 2 cos theta minus 1 multiplied by cos theta plus 1. So 2 cos theta minus 1 times cos theta plus 1. If this is equal to 0, then it's going to be undefined. But they didn't just say, oh, okay, tell us how it's going to be undefined. They want you to find the values of theta for which it will be undefined. So this is kind of like general solution. This is general solution. You have to actually solve for theta here, generally. They didn't ask you to solve for theta within a specific interval, okay? They didn't even give us any intervals here. So this is general solution, really. It's a general solution question. Okay, so how do we find this? How do we solve for theta? Does this look familiar to you? You have two things being multiplied and they're equal to 0. Just like that, for example, right? You would make that bracket equal to 0 and say, oh, this bracket is equal to 0. Same thing that's going on here. We're going to say either 2 cos theta minus 1 is equal to 0 or cos theta plus 1 is equal to 0. Then here, I'm just going to move these apart because they're going to become huge. Okay, so I'm going to just move that there, here. Okay, so looking at this, we have 2 cos theta, and I'm taking negative 1 over the equal to sign and it becomes a positive 1. Divide both sides by 2, and we have cos theta being equal to 1 over 2. That's the first solution for cos theta. Let me also just clean that up. So we're taking positive 1 over and becomes a negative 1. So cos theta being equal to negative 1. Okay, now I'm going to concentrate on this. We need to solve for theta. It's like general solution, solving for theta. Finding a general solution for theta here, you have to do this. We're going to have to take cos over to solve for theta. But be careful. What we find here technically is not going to be theta. It's not necessarily theta itself. It's just a reference angle. Okay, I'm going to call that reference angle. I'm taking cos over, and so when cos over, it becomes the second function of cos, which looks like that. Okay, so I'm going to actually find that on the calculator. That is shift cos of a half, and I will perfectly just put a half because it is a positive number. I don't have to overthink it. It said cos. Shift cos of a half. Okay, and we get 60 degrees. That's our reference angle. So you see, that's from taking that over. Okay, we get 60 degrees as our reference angle. Now we actually have to solve for theta. Look at how we're going to solve for theta. You're going to say that we're seeing the fact that cos, right, of theta is equal to half, meaning cos is positive. Think about the quadrants where cos is positive. There are different ways of doing this. I have my own special way of doing this. I actually don't use this method, but I do use this method when tutoring, because I know that most teachers actually do use this method. So where cos is greater than 0, this is the quadrants that we're going to have to look at. Where is cos greater than 0? Cos is greater than 0 in the first quadrant and in the fourth quadrant. You're going to have to use the reductions of the first and the last quadrant. So the reduction of the first quadrant, that's just theta. So whatever your reference angle is, that's what you're going to use. And then the last one is 360 degrees minus theta. Okay, that's cos. So this is where everything is positive. That's where cos is positive. So this is how I'm going to solve for this. I need to keep this apart. I need some space here. Okay, so this is how I'm going to solve for this. I am saying now the answer for theta, that theta, you see, so whatever function you have here, whatever you have here, you're going to take that and you're going to say that is equal to, and we're going to start with the first reduction where cos was positive was in the first quadrant, and we just have theta. Theta stands as your reference angle. So we're just going to take whatever our reference angle was, and I'm going to put it down 60 degrees. And now I'm going to say plus k of 360 degrees. I know most people say 360k. I say k 360 because sometimes I forget that k when I'm writing fast. So I make sure to put it first. Okay. Theta is equal to 60 degrees plus k 360. Now you see, you have to say plus k 360 because the cos graph repeats itself every 360 degrees. We're saying that we have a solution at 60 degrees and this answer will repeat itself again every 360 degrees. We have to do this because this is a general solution. They did not say find the values of theta where theta is an element of, let's say, 0 degrees to 180 degrees. They didn't give you a restriction. They didn't give you a domain to stick to. So it's a general solution that we're finding. Okay, so we've got the first solution for theta. Then we're saying, or again, you're saying theta is equal to whatever answer you had there. Theta is equal to, and we're looking for the second place cos was positive, which was in the fourth quadrant. We will use that reduction. We're saying 360 degrees minus theta, and theta is our reference angle, which is 60 degrees, okay? Minus 60 degrees, and I'm already going to just find that answer. 360 minus 60 is 300 degrees, so 300 degrees. And again, this answer will repeat itself every 360 degrees, so plus k of 360 degrees, okay? And you can say where k is an element of real numbers. You only need to say it once though. So I could have said it here, but I think I'll just say it there. Okay, so these are all my solutions for theta. So that was the first thing. I think I'll leave this. I'll use this again if we need it in this one. Now in the second one, that's our solutions for theta for the first one. That's what theta must be for it to be undefined. Now this one says cos theta is equal to -1. And I'm glad they put this so that you can see what to do now when your value is negative. Okay, using this same method, right? When we're using the reduction method, what you're going to do is, again, we're going to take cos over, and this is finding the reference angle. Now, when you're taking cos over, I know it seems like we're going to say the second function and then -1. No, we're not going to use -1. You're going to take the absolute value of this number. So regardless of whether it's positive or negative, we're only going to take the number we see. I know I see -1, but I'm going to take it as a positive number. So of +1, that's what I'm going to use. And if you do find what the second function of +1 is, it's 0. Okay, so here our reference angle, I'll just leave that there so that you can see how to find that, is 0 degrees. Okay, now the second thing we need to look at is the fact that cos theta was equal to -1, meaning cos is negative. So we need to find which quadrant is cos negative in. Cos is negative in the second quadrant, which is sine's quadrant, and the reduction for that is 180 degrees minus theta. And it's also negative in the third quadrant, which is tan's quadrant, which the reduction is 180 plus theta. So we're going to actually use those reductions for this. So now, when solving for theta, we're saying theta is equal to, and we are going to use the reductions of these two. So 180 degrees minus our theta, which is our reference angle, which is 0. So minus 0 degrees, and then of course plus k of, this is still cos 360 degrees. Okay, now I'm seeing something here. If I say or theta is equal to, and I use this one as well, I say 180 degrees plus 0, okay, degrees, plus k of 360, because of course I'm using that, and theta, okay, is our reference angle. Do you see that you're going to get the same thing? 180 minus 0 is 180. 180 plus 0 is 180. You don't have to write the solution twice. So I'm going to keep it as one of it, okay? So 180 minus 0 gives me 180, so I'll just leave it as 180 degrees. So there, these are our solutions, and I still need to say where k is an element of. So, or that's the second one from here, and I need to tell them that k is an element of integers only, okay? Not whole numbers, nothing like that, just integers. So there we go. These are our three solutions of theta. If you want that identity above to be undefined, theta must either be equal to 60 degrees plus k 360, 300, or 180, of course, plus k 360 degrees. Okay, so there we go. That is a general solution question. And moving on to the next question. Okay, now we're in 5.3, which is the last question for question 5, last set of questions. And we are told this. In the diagram below, A is a point on the Cartesian plane such that angle AOT is equal to alpha. So here we have this point A is B and 1, okay, and AOT, that is the full size of alpha, okay. Alpha with AO being equal to 4, we have AO, okay, so they gave us the length of that radius, it's 4. Then they tell us that P, which is K and M, is a point such that OP is equal to 6, also have the radius, and AO is perpendicular to OP. A lot of information here they're given. AO perpendicular to OP, so we have a 90-degree angle over there. Okay. Next, first question is 5.3.1. Determine the value of B. Okay, this is not that bad. Finding the value of B, you just have to think about it like this. You have OA or AO, and that's 4 units, right? You also have the coordinate of A, which is B and 1. First of all, you can draw a line down to the x-axis, and this line of course is always going to be perpendicular to the x-axis. So here's your right angle triangle. We can also just figure out what the other things are, what your x value is. Please note this is the x value. You see, this would be an x value, like a normal point, right? It's on the x-axis. So the x coordinate, that's your x value. And the y coordinate would be this, okay, the length of that, because we're saying that is how high that is. It's a y value. So the y coordinate is that. So we know now the x coordinate is B and the y coordinate is 1. That's what we have here. We also have a radius of 4. So we just have to find B. As you can see, we can just use Pythagoras. We have a right angle triangle. One thing is missing. We have the opposite and the hypotenuse. So we can use Pythagoras on that. Okay, let's go ahead and work on that one. So we just go ahead and say, okay, we just need to find the value of B, and you can make B the subject. If you like, you can rewrite it as x squared is equal to, and then you're going to say it's the radius, the hypotenuse, r squared, minus, okay, the opposite side, which is of course the y value, y squared. You can do that, but you could have also just started with B, it's fine. So the x value is B, okay, that's B squared, is equal to, the r is 4, so that's 4 squared, minus the y value is 1, okay, y value, that's 1, okay, that's 1 squared. And let's go ahead and find that. B squared is equal to 4 squared is 16, 1 squared is 1, 16 minus 1 is 15, so we have 15. Then you have to square root both sides. Here's the thing about this. You're solving for b, which is an x value. It's not r. So because you're solving for b and this is an equation, the highest exponent is 2, meaning you have two possible solutions. You need to remember to include plus and minus. And this is very important in trigonometry, especially trig diagrams, because as you can see, do you see where b is on this Cartesian plane? It is on the negative part of the x-axis, okay, of the Cartesian plane. So it's definitely a negative value. If you square root 15, you will not get a full whole number. You will get a third square root 15 still. So this means that b is actually just equal to the negative square root of 15 because it's on the negative part of the x-axis. So please be careful of that. So b is equal to the negative square root of 15. And there we go. So that is our answer. I don't think we have to round off because we're probably going to use that still. Okay, moving on to the next question. And now they say, determine without the use of a calculator the value of, and the first thing they want us to find the value of is tan of alpha. So the value of tan alpha. Okay, no problem. They told us that alpha was measured like this. So that whole thing is alpha. So tan alpha, we just need to find what tan is going to be for this triangle. See, because it's going to this triangle. That's alpha. Okay, tan speaks about, remember SOHCAHTOA, opposite over adjacent. So it's the opposite side over the adjacent side. So we're going to look at it like this. Our reference angle is alpha, which we're looking at it like that. It's here because, of course, of the reduction. That reduces it to this little thing. So the opposite over the adjacent, that's going to be 1 over negative square root of 15. And that's tan alpha. Okay, tan of alpha is equal to 1 over the negative square root of 15. That's all we have there. Okay, and then the next question is this. Just know that this is just here because this is the paper when it was, I think it was still in its editing phase. So they just forgot a bracket there. So that was just a comment that was made. Okay, the second question is sine of negative alpha minus 180 degrees plus cos of negative alpha. Okay, so it's probably just, we'll need to just do some simplifying. Let's see. Sine negative alpha minus 180 degrees plus cos of negative alpha. Nothing to be worried about. It's just a little bit of simplifying that needs to be done here. The first thing I like to do is I like to write these reductions or these values as first I need to have the angle and then of course the alpha or theta, whatever. So I'm going to rewrite this as sine of, and I'm going to put the negative 180 first. Just want to, put it in that order. Negative 180 degrees, and then I have a negative alpha. Okay, plus cos of negative alpha. And now we have to think about the rules to add here. Remember when I told you about that, those two rules you need to think about with reductions? You have to think about whether the angle is over 360 degrees or whether it is negative. If the angle is negative, what do? You add 360 degrees to it. If it's over 360, you subtract 360. So I'm looking at this angle and I'm like, okay, this is already negative. Then you have minus alpha. So it's definitely a negative angle. So what should you do to it? Add 360 degrees to it. And add 360 to that. And I see the same issue here. This is a negative alpha. I may not know the size of alpha, but I know that alpha stands for an acute angle, okay? Because of the reduction when it gets reduced. So I'm going to say it's negative, so I need to do what? Add 360 degrees to it. So I'll add 360 to that. Let's see what we get. When we have this is sine, and we have 360 degrees minus 180. That's positive minus 180. Okay, so that's 180 degrees minus alpha. Then we have plus, and here we have cos. We have 360 degrees minus alpha. If you just fill it in, that's really what we have there. And now we just reduce. And now all we need to do is just reduce. So we have sine 180 minus alpha, same thing as your reductions. Think about where 180 minus alpha is here, okay, minus theta or alpha. And sine is positive in this quadrant, so this becomes a positive sine alpha. And then we have plus cos 360 minus alpha. In fact, cos actually is positive in that 360 minus theta, so it stays positive cos alpha. Okay, so there, this is simplified. Now we just literally have to find what sine alpha is and cos alpha is, just like we found with tan alpha. Okay, sine alpha on this. Remember sine, saw, okay, is sine is opposite over hypotenuse. So the opposite is 1 over the hypotenuse is 4. So that's 1 over 4. 1 over 4 plus cos alpha. Cos is ka, which is cos is adjacent over hypotenuse. So that is the adjacent side, which is here, negative square root 15 over hypotenuse 4. So negative square root 15 over negative square root 15 over 4. Now, I know there's a confusion here. There's a plus and then there's a minus. You can just put a bracket to separate them. So if you're simplifying this, you can put this on the calculator. It will give you the answer. And I'm just going to do that because it's really not necessary to start, calculating it like that. No, actually you can. It's really not that bad. It's 1 over 4 and then positive times negative is just negative square root 15 over 4. And so the denominators are already the same. So I just have to put the numerators together and they will be under the same denominator if you use the calculator to give you this answer. So that's just 1 minus the square root of 15. That is our answer. 1 minus the square root of 15 over 4 is all of that. Okay, so you see, don't panic when you see things like this. The good thing is alpha was there. Okay, we know the diagram that has alpha, so you can actually simplify it. Okay, moving on to the next question. And then the last question, 5.3.3 says, without the use of a calculator, determine the values of K and M. Okay, so let's see how K and M relates to everything that we have. So K and M are the coordinates of P. So K is the X and M is the Y coordinate. So if I also draw a line down to the X-axis like this, this is what we have. Here we first have the K is the X value, okay? So it's going to go wherever X goes. The X value always goes down here, okay? Because it's like, this is an X value on the X-axis. Okay, so that is K. So let me put that in red. That is K. And then M is your Y value. So Y value would go here, parallel to the Y-axis. So that is M. We have to find K and M given everything that we have. Okay. The good thing about this is, you see this triangle, in order to even use M, K, and even this radius of 6, is that you have to find what exactly this reference angle in this right angle triangle is. Now, they already told us that this angle, they told us that the angle AOT, right, is equal to alpha. This entire thing is alpha. But remember, they also told us that this is 90 degrees, where they gave us about those perpendicular lines, basically. So if you want to find this angle in between here, what you're going to have to do is see how it's created. This angle is created like this. You see this angle, alpha. If you take that full angle and you subtract it by this angle over here, you'll be left with this angle. So if we say alpha, an entire angle of alpha, and we say alpha minus this angle in between here, which is 90 degrees, as we can see now, minus the 90 degrees, it's going to give us that angle over there. And I'm just going to call this angle by its name. It's POT, that angle. So that is the reference angle for this right angle triangle. Okay, so it's going to give us the angle POT. So that's POT. Okay, so that's the angle we're going to have to use. Now, the good thing about this is that it includes alpha. So first I'm going to state that down. Angle POT is equal to alpha minus 90 degrees. POT equals alpha minus 90 degrees. Okay, it includes alpha. That's good. So we can actually find this. Now, in order to find m, if we're looking at this triangle, m is the opposite side, okay, in reference to this reference angle that we're using. Let me even write this in blue, POT, okay, in reference to this angle. It is opposite. And then we need to use a side that we already have. So we're going to have to use opposite over the hypotenuse, which is 6. So that would be the function sine. We'd have to use the function sine to find this. So really just saying that sine of this angle, alpha minus 90 degrees, our reference angle in this triangle, that is going to be equal to our opposite, which is m, over our hypotenuse, which is 6. Okay, let's put that down first and let's see how we can find m using this. Okay, so now that we're at this point, this is going to become an equation where we're going to have something on this side and we have this, and this will help us to solve for m. The only thing about this is right now, this, well, it doesn't really mean too much yet. We need to simplify it so that it can just have theta and no other angle here. So we're going to have to simplify this part further. Okay, how can we simplify sine alpha minus 90 degrees? Well, first of all, there's two ways of simplifying this. But the thing about the general way that people use, where they kind of look at it like, oh, this actually looks like cofunctions. And it is, can be used as cofunctions. It is cofunctions. But the thing about it is you need to be careful when using these. Now, I don't want to make the video long, but I also feel like it's something that I should also explain as well. First of all, to make this look better, I'm just going to rewrite this by writing the negative 90 degrees first. Okay, so this is sine of a negative 90 degrees and then our positive alpha, right? It's still equal to m over 6. Still have that. Okay, the thing is, we're trying to simplify this. Now, I'm going to give you a rule. I'm going to try to help you with this. The thing is, I would have explained it in more detail, but I'm really thinking I shouldn't do that because it's going to make this video long. If it is sine that you're working with, you're safe and you can actually do what I'm about to do now. Okay? You just need to be careful for cos. And I'll explain why. So here, this is what we have. When we have sine negative 90 degrees plus alpha, what you can do, let me show you the correct way of doing this or how the answer actually comes about. You see, if you have sine negative 90 degrees plus alpha, we're going to look at the fact that I'll do the quick way on the other side. But I want to show you where it comes from. We're looking at the fact that this angle over here is negative. What do you do when the angle is negative? You add 360 degrees to it. Okay, you see we have a number angle that is negative. So we need to add 360 degrees to that. If you say negative 90 plus 360, you're going to get 270 degrees. Now, I know this looks weird, but here's where the cofunctions come. We're going to say sine of, and 270, I'm going to take this and I will break it up. I will break it up so that it can form a cofunction. So I'm going to remove a 90 from it. So I'm going to break it up as 90 degrees plus, so 90 degrees plus what gives you 270? It's 90 degrees plus 180 degrees. Then I'll say plus alpha. Okay, and this is why I was doing this. I'm going to treat this as cofunctions. We have, in cofunctions, we usually have 90 degrees plus theta and 90 degrees minus theta, right? I'm going to leave the 90 degrees on its own and I'm going to group these two together as if they are a theta of their own. So if I did that, we would have sine. Now I'm going to have to basically change it using cofunctions. If you had, let's look at this, sine 90 degrees plus 180 plus alpha. I'm treating this as if it is a theta of its own. Which cofunction would it be? Would it be sine 90 plus theta or sine 90 minus theta in this situation? It would be sine 90 plus theta. Here's why. You have 90 degrees, you have plus, then you have your angle. I'm treating this as if it's theta. And you know that sine 90 plus theta, okay, it's still just sine 90 plus theta, is equal to cos theta. Okay, it gives you cos theta. Remember, my theta here is this entire 180 plus alpha. So if I simplify this, this is actually cos, and then it's supposed to be cos theta, but my theta here is the 180 plus alpha, so it's cos 180 plus alpha, right? So now that I have this, if you reduce this, cos 180 plus alpha, this is not cos's quadrant, this is tan's quadrant, so this will become negative cos alpha. This is the correct way of doing this. Now, this is why I said if you are working with this shortcut, if you deal with this using the shortcut, okay, if you have the function sine, you're safe. You can use the shortcut. It's not going to affect it. But you need to be careful when you see cos. And we will see cos in this question. I can see from the way that thing looks. So let me show you now the shorter way of doing this. I'm showing you how it comes about. You see that this becomes negative cos alpha. Most people will look at this and say, oh, I can take out a common factor inside here. And you can. You can take out a common factor. And if you take out a common factor of -1 so that that can become positive, the common factor goes outside. It's now negative. And then we have sine of, now this now becomes positive 90 degrees. And this becomes negative alpha because of the common factor that we took out. Right? So now that we have this, we're still saying that it is equal to m over 6. Okay? Equal to m over 6. And now, look at this. Sine 90 minus alpha is a cofunction. Sine 90 minus alpha becomes what? Cos alpha. But remember, you still have your negative. So I have my negative. Then the sine 90 minus alpha becomes cos alpha. And I'm really just saying that cos of alpha, negative cos alpha, is equal to m over 6. Now, this is good. We can actually work with this. You see, so you can take out a common factor, but remember I said when it is sine, it is safe to take out that common factor. I'll show you what happens when it's cos. Okay, so this is what we have. Negative cos alpha is equal to m over 6. Okay, we actually have the value of cos alpha. You see that in the previous question, they told us to find sine alpha plus cos alpha. This is why I said when it has alpha in it, it's a good thing because you can simplify it and it's going to give you a single trig function that's going to have alpha like that. Okay, so because we already know in this other diagram, we know how to find cos alpha. Okay, in this one here, cos is adjacent over the hypotenuse. And we already know what it is from the previous question. The previous question usually helps you with the next question. So cos alpha was negative square root 15 over 4. So that's what I'm going to replace here. But please don't forget you have a negative here. You have a negative outside, and we know that cos alpha is equal to negative square root 15 over 4. And all of this is equal to m over 6. We can actually solve for m right now. So this now multiplies in and becomes a positive square root 15 over 4 is equal to m over 6. Then we need to solve for m. Focus on solving for m. To solve for m, you need to get rid of the 6. The m is being divided by 6. So to get rid of the 6, you need to multiply by 6 on both sides because this is an equation. So it would mean that m would be equal to, it's definitely still going to be a third. I'll just find the answer like this. So 6 multiplied by the square root of 15 over 4, and that, I'll keep it as a third, is actually going to be 3 square root 15 over 2. I know it's put in as 3 over 2, but then I'll just put that both on the numerator. Your calculator will probably write it like this. Okay, so that's m. And then we have to also find the value of k. Okay, so now we have to find the value of k, and we're going to use a similar method as well. We're going to look at the fact that we have been given a hypotenuse already. The hypotenuse is 6, and we want to find k. So it means that we have to use k, which is the adjacent side, and we have to use a side that we have already been given, which is the hypotenuse, 6. So think about it. We're using the adjacent and the hypotenuse. So which function is this going to be? It's going to be cos. So we can find cos of our reference angle. So I'm really just saying here, we'll be saying that cos of our reference angle here is this alpha minus 90 degrees. And this is equal to, so cos alpha minus 90 degrees would be equal to your k over your hypotenuse, which is 6. Okay, that's what I'm going to use, and I'm also going to simplify that. Okay, so cos alpha minus 90 equals k over 6. And we have to simplify cos alpha minus 90. And here, this is why I said you need to be careful when it's cos. I know you're like, oh, I can just take out a common factor. Be careful. Look at this. If I work this out the normal way it's supposed to be worked out, cos of alpha minus 90 degrees, right? Look at what's going to happen here. Okay, this is equal to, again, I will write it in its proper format where the angle comes first. So I'm going to say cos, and this is my angle. It's negative 90 degrees plus alpha. And this is equal to, and now I see that, okay, the angle is negative. When angles are negative, I'm just going to add 360 degrees to it. Remember, this is the long method. I'm just showing you, like, if you were actually finding the actual value of it before just deciding I'm going to take out a common factor. The common factor method may not be correct. Okay, it only works for sine. That's what I've noticed. It does not work for cos. If we go ahead and add 360 degrees to this, we're going to get cos 270, and remember we're adding 360 because the angle is negative. Then we have plus alpha. Okay, then I need to form cofunctions here. So from the 270, I need to break 270 degrees up into 90 degrees and something else. So that's going to be cos, I'm saying 90 degrees. Okay, let me even put this in a color. So 90 degrees, and then we have plus what gives you 270. That'll be plus 180 degrees. Okay, then we still have the plus alpha. Now, I'm trying to use cofunctions on this. I have my 90 degrees, so I'm going to group this angle as one angle. Just like in our cofunctions, we know that cos of 90 degrees plus theta is equal to negative sine of theta, right? This is a cofunction, we know that. I'm going to treat 180 plus theta as if it is a 180 plus alpha, sorry, as if it is a theta on its own. So this is what's happening. I'm saying this is going to simplify to, it's the same thing as 90 degrees plus theta, right? It simplifies to negative sine of theta. So this simplifies to negative sine, but my theta here is this 180 plus alpha. Okay, negative sine 180 degrees plus alpha. Okay, we're done with that part now. And now that we have this, if you simplify this, negative sine 180 plus alpha, it's actually negative sine, oh, I can't really do that, negative outside, sine 180 plus alpha. 180 plus alpha is not sine's quadrant, this is tan's quadrant, so it means that sine is negative in this quadrant. This negative is already on the outside, it's not for this. So bracket, this part becomes negative sine of alpha. Okay, then your final answer is actually sine alpha. You see the correct answer. Let me show you why I said be careful when you see cos in the case of a negative cofunction. Okay, when you see that 90 degrees is negative, and why I don't say recklessly just take out a common factor. Look at what happens here. If I had to use the method of taking out a common factor, I would have first of all said, okay, fine, let me rewrite it in a way that 90 comes first. So that's negative 90 degrees plus alpha is equal to k over 6. Then I would take out a common factor, okay, negative cos of positive 90 degrees, and this becomes a negative alpha is equal to k over 6. Now look at the thing about this. This is cos 90 degrees minus alpha. It's a cofunction. You know that cos 90 minus theta is equal to sine theta. Doesn't change the signs, okay? It's just positive sine theta. It's only that, of course, cos 90 plus theta, that becomes negative sine theta, okay? So look at what this becomes. We still have the negative on the outside that we took out as a common factor, right? We have a negative, and then this now becomes sine of alpha. That part becomes sine alpha. Do you see a problem here? I know this is the correct answer because this is the manual way of doing this. And even if you check it on you can even check it on Photomath, okay, on the Google Play Store Photomath. If you check it and you check for this, it's going to give you this answer because this is the actual correct answer. And this is why I say when you see cos in negative cofunctions, please be careful. it doesn't really just work by taking out a common factor. So here's my solution to this. Whenever it is cos, whatever your final answer is, multiply it by -1 so that you can get the right answer, because we know it's supposed to be positive sine alpha, not negative sine alpha. Okay, so that way that will always work out. So do this whenever you see cos and it's a negative cofunction. Okay, then you are free to take out a common factor, but just make sure if it is cos at the end of the day, multiply your answer by -1 so that it can be correct. So it's equal to k over 6. Okay, then I'm going to say this is sine of alpha. It's positive now, sine alpha, because I know that's the correct answer. It's k over 6. And I'm going to do the same thing I did here, where I found what cos alpha was here in the other diagram. Here I'm going to find what sine alpha is. Sine alpha in this diagram here, sine alpha was 1 over 4. So I'm going to use that, okay? Remember, it's like here. In your diagram, this was alpha. Sine of alpha is the opposite over the hypotenuse. That's why when you see alpha, it's okay, it's good. You just have to make sure that you simplify whatever they ask to a single trig function that's going to have alpha in it. And there. So this is now 1 over 4 is equal to k over 6. Okay. So now we can solve for k. We need to get rid of the 6 to solve for k. So multiply both sides by 6. And so our answer for k is just going to be equal to what is 6 over 4 really, which is going to be 3 over 2. 3 over 2. Okay, so that's our answer for k. I know that explanation was long, but I really just wanted you to understand about that cos. Be careful with it with negative cofunctions. But don't worry, this doesn't work for like just the normal cofunctions, something like cos, 90 minus theta. You just find the answer, that's sine theta there. But just be careful for negative cofunctions so that you can go ahead and take out a common factor, because it is quicker. You saw how long this took. Okay, but just remember, if it was cos, multiply your answer by -1 so that you can actually get the correct answer. Okay, please also comment if you understood it or not as well. So maybe I could even just make a separate video on it, because it will be useful for grade 12 as well. Okay, so that was the last question for question 5. Question 5 is worth 27 marks. And then we move on to question 6. Okay, so we're going to question 6, but I just wanted to note, I noticed that I made a mistake here. This should still be a 15, okay? Square root 15 and then over 2. Okay, now we move on to question 6. Okay, so question 6 says, in the diagram below, the graphs of f of x is equal to a sine bx plus 1 and g of x is equal to 2 cos x plus p. So this is a left or right movement, are shown for the interval where x is greater than or equal to -90 but less than or equal to 180 degrees. And then we have some questions. Okay, so let's go ahead and start with 6.1. So question 6.1 says we have to write down the amplitude of g. Okay, so to write the amplitude, I suggest you first of all look at the graph of g. See, look what the graph of g looks like. As you can see, this graph is not being shifted up or down. If it was shifted up or down, you would have something here like +2 at the end outside the bracket, or +1 or even -1. You'd have some sort of number at the end. So the good thing is that it hasn't been shifted up. So the amplitude is going to be very clear here. Whatever the absolute value of this number is, and there's a reason I'm saying absolute value, because sometimes you can have a negative number, okay? But in this case, it is positive. You take the absolute value. So regardless of whether it is negative, you're just going to take the value of that number. If it was -2, you're just going to take 2. That would be the amplitude. And just remember, the amplitude of a graph is really just the height, okay? The height of it from its midline. So this would be the middle in terms of this graph, of course, this one. So the height of this graph is, it's going how high? 2 units high. That is the highest it can go. Okay, so that is the amplitude, and we can clearly see it here. Always take the absolute value of whatever you have here, as long as it has not been shifted up or down. Okay, so the amplitude of that graph is just 2. Okay, moving on to the next question. And then the next question is we have to determine the period of the graph of f. Okay, so to determine the period of the graph of f, so I'm just looking at the graph of f. Let me highlight it in a different color so I know that I'm just going to always keep this as f. Okay, so this is the graph of f. The period of it, well, there's a number here that's supposed to be here in place of b. If the number was clearly seen there, it would have been easy to find the period. Okay, to find the period of that graph, we would have just said the old period divided by whatever number was here. Okay, and what I mean by the old period is the original period of the function that you have here. We have the sine function. The sine function has an original period of 360 degrees. It takes 360 degrees for it to complete one cycle. Okay, but as you can see, they didn't give us that number. So we're going to have to look at this and just see how fast does this thing complete a cycle. Okay, so just remember we're speaking about the graph of f, right? The graph of f, this graph, this one here, okay? So if we know that that is the graph of f, also remember that this graph has been shifted up. So it has been shifted 1 unit up. Naturally, it was supposed to look like this. Let me even just draw it out. Okay, so naturally this graph is actually supposed to look like this, like where it is, it's supposed to actually go down like that, right? But it has been shifted up. So I'm just doing this just so that you can see what it's supposed to normally look like, the original sine graph. And then from this, we can even be able to tell what exactly the period is. You need to remember what a cycle in a sine graph looks like. The sine graph, if you went to go draw a graph and you started drawing or putting down angles from 0 degrees all the way to 360 degrees, okay? Make sure you put it in intervals of 90 degrees. So 90, 180 to 70, 360. You will notice that your graph will do this. That's the normal sine graph. Y equals sine of x, right? So this is one cycle. A cycle is just how long it takes the graph to repeat itself. So if I had to continue past 360, we'll have another shape that looks exactly like that. Again, okay? So what we're trying to look at is we're trying to see one full cycle in this graph above. And when we catch that one full cycle, we're going to see how long it took to complete that cycle. Okay, so this is what I'm going to do here. Okay, so I'm even looking at the sine graph and I'm noticing it looks strange because I thought at first maybe it was shifted to the left or right, but it's not being shifted. We just have bx, meaning the period is being affected. So what I did notice, and it's probably going to come in handy in the next question, what I've noticed now is that this sine graph that we have here, look at, if we were starting from 0, you see, this is one cycle. That's one complete cycle. The only reason why it doesn't look like this one is this one, its a value is clearly negative. That's what's going on. So if it was positive, like y is equal to positive sine x, then it would look like that. But this one is kind of like doing the opposite. It's almost as if it has been reflected through the x-axis. It's like upside down, really. Okay. So now that I noticed that, we're seeing that one cycle is completed from 0 degrees to 120 degrees. So it means that the period of this graph is 120 degrees because it has completed one cycle within a period of 120 degrees. Okay, so I'm going to put that down. The period of the graph is 120 degrees. Okay, moving on to the next question. Okay, and then 6.3, determine the values of A, B, and P. So just like I said, they'll probably ask that in the next question. So A, B, and P, let's go ahead and find this. So with A is actually quite simple. You see, the minute you do that, you should always try to put the graph, you should always remember the way the original graph looks, and then you'll be able to see what they started doing to this graph here. Okay, so you see that this graph, the sine graph, right, F, I pulled it down just so that it looks more normal. And remember I told you that this thing looks as if it has been flipped upside down, right? And I said the only way that it could have done that is if this was negative. Now, we need to know what exactly that value is going to be by A. What is it? It's negative something, but what is that value? Well, if it was, for example, negative 2, then your maximum, you see that the highest point that the graph should have gone, because I pulled it down just so that it can be more understandable. The highest point that graph would have gone would have been 2. Okay, that means the amplitude of the graph would have been 2. But that didn't happen. As you can see, it's still 1. The lowest is still -1, of course, when we pull the graph down so that it can be in line with the x-axis. So it means that the number that we have there, since we can see the amplitude of this graph is actually 1, okay, it means that the value of A, that number here, is -1, okay, because the highest point is going is 1, the lowest point is -1, and we can see that it doesn't look like the normal sine graph. It looks like a sine graph that was turned upside down. So it means that that coefficient of sine of x is negative. So that's how I know it's A is equal to -1. Okay. So the shape of the graph really matters a lot. The way it looks. It should look like a normal sine graph. Okay, moving on to the next question. Okay, now the next question. We still have to find B and P. So B, where is B? B is over here. So what number would be here in the sine graph if we now know that the period is 120 degrees? Okay, there's actually a way to find this. To find out the number that has been placed here. Remember, the normal sine graph, right, is supposed to complete one cycle within 360 degrees. But this one is completed a cycle within 120 degrees. Okay, so notice it's also completing the cycle faster. So if you look at compare 360 to 120, how did we get there? It's by dividing by something. It's by dividing by 3. So how you can find exactly what that value is going to be is we're just going to say, and let me even explain it like this. Remember, I was showing you how to find the new period of a graph. I said that if you wanted to find the new period of a graph, you say the old period divided by whatever number is in front of x. Okay? In front of x, not sine. In front of x. And we can see that is b. So in order to find this, look at, I could even use this equation and I'll find it still. So I could just say the new period of this graph that we have here has a period of 120 degrees. So it has 120 degrees, and I know that the old period of this graph is 360 degrees because it's a sine graph. So I can say it's equal to 360 degrees over b, and then I can just solve for b. So if I need to solve for b here, I can just cross multiply. 120 times b is 120 degrees b, which is equal to, we have really a placeholder of 1 here as a fraction. So that 1 times 360 is still 360 degrees. And then if you divide both sides by 120 degrees, then you'll see that b is actually equal to 3. Okay, so that's an equation way of finding that. So remember this formula. It's to help you find the period of a graph. To find the new period, you say the old period divided by the coefficient of x. The number in front of x. Okay, so we have found the value of a, the value of b, and now we have to find p. Okay, p is part of this cos graph. So the cos graph says 2 cos x plus p. 2 cos x plus p. Let me actually just get rid of these. I hope I will not need it again. But let me highlight the cos graph so that we can just look at what happened to it. Okay, so first of all, the first thing I'll look at with this cos graph is the fact that it says 2 cos. So the amplitude is 2. It means that the highest point of this graph is going to be 2 and the lowest point is -2. Okay, so that has already been changed about the graph. But either ways, it's still supposed to look like a normal cos graph. I know that the cos graph goes as the highest is 1 and the lowest is -1. But if we look at this graph, let's think about what the normal cos graph looks like. You can always find the normal cos graph because you have a calculator. See, if you take your calculator and you say, let's start from 0 degrees, okay? It's always easier to start from there so we can see how it looks. If you started from 0 degrees and you said cos of 0, it gives you 1. So it means I'm just trying to show you what the cos graph naturally looks like. Cos of 0, you get 1, right? Then if I said cos of, let me even put this in a different color because I'm going to draw the graph differently. And then if you had cos of, okay, to make this simpler, instead of saying cos, I'm going to say 2 cos because this one already has 2 cos. I'm just trying to find out how it shifted. You see, it says x plus p, And when you're affecting the x, when you're adding or subtracting to the x in all of functions, what you're actually doing is shifting this graph either to the right or to the left. So I'm just trying to find out how it was shifted. So I know what the normal cos graph looks like, but I just want to show you that you could actually draw it yourself. So if I said 2 cos, because this one also has 2 cos, so I'm going to use this graph and just find out now what it's going to look like. I would have had 2, so I'm plotting 2. Then if I try, let's go in intervals of like 90 still. So if I now substitute in place of 0, I put 90 degrees now. So 90, let's see what we get. We get 0, right? And then if I substituted, of course, 180, then I'm going to get -2 and so on. -2 at 180. Now this interval, okay, it doesn't really go that far. But if we had this graph and, okay, just for the sake of understanding, I'm going to substitute -90 as well, just so that we can see what this would look like. And cos of -90 is 0, so it would have been on here, right? Okay, so this is kind of what our graph looks like. It's doing this and doing this. Okay, that's what our cos graph is doing. So if we're seeing this graph and we're trying to understand it, like how did this graph move to become like the red graph? So which direction do you think we moved the blue graph to get to the red graph? We moved it to the left, okay? We moved it that way. That's what happened to that graph. But now we just have to find out how many degrees that way did it move. And how you can find this out is by taking one of the points that you can easily see, where you can see an x value. And what I mean by that is, like, for example, here at positive 90, at positive 90 degrees, I know that this is where this point is right now. When it shifted to the left, it went to positive 60 degrees. So think about it. How much degrees to the left did we move this graph from 90 degrees to 60 degrees? We moved it how much degrees? We moved it by 30 degrees. So now we can see that this graph moved 30 degrees to the left. Okay, so now that we understand how it moved, how do we apply that here? If it moved 30 degrees to the left, this is the thing about left and right movements. They don't work like up and down movements. Up and down movements, if something moves up, you say plus whatever the number is that it moved up by. If it moves down, you say minus whatever the number it is that it moved down by. But this is not an up or down movement. It's a left or right movement. So it goes the other way around. Because this moved 30 degrees to the left, I know you'd have thought I would say minus, but when something is moving to the left in the function, okay, you say plus. So what would be here to be 2 cos of x plus 30 degrees? Now do you see the value of p? Okay, so the value of p is 30 degrees because it shows us that the graph moved 30 degrees to the left. You see how important it is to know what the original graph looks like. That's why in grade 10, they gave you guys graphs to just continue drawing. It was so that you could be familiar with the way these graphs look. Okay, so lastly, p is equal to 30 degrees. And it's the only one in degrees, of course, because it is a shift. These ones are just y values, really. They're just values. Okay, so this is what we have. And we have all of these done. And we can move on to the next question now. And question 6.4, they say determine the value or values of x such that g of x is greater than 0. So this is just graph interpretation. So I'm going to get rid of all these drawings because it's not really necessary for this. Okay, so the question wants to know, where is g of x greater than 0? And not greater or equal, so just greater than 0. So I'm going to look at the graph of g and check for all the places that it is greater than 0. Please note, where g is greater than 0, this refers to the y values of g. Because remember, g of x, it stands for y. It's saying where are the y values of this graph of g greater than 0. Now you know that the y values that are greater than 0, if we're looking at that on the y-axis, because we're looking for y values, you know that those values would lie here. Everything here has a y value greater than 0. So it means that when you're looking at the graph, you cannot take anything down here. Because everything down here has a y value that is less than 0. See? Y value less than 0. So we're only going to look above the x-axis, every part of g that lies above the x-axis. Okay, so let's highlight exactly where that would be. The parts of g that lie above the x-axis is all through here. Here, all of these have y values greater than 0, and I keep going until there. Okay, that's the last place. So what would be the x values for which these have y values greater than 0? Well, if you lined it down to the x-axis so that you can see what exactly these values are, you see that these are values that start at 60 degrees. Okay, at 60 degrees, the y value of g is 0. So I can't really take 60 degrees itself. Like I can't say g of x is equal to 60 degrees because at 60 degrees, g is equal to 0. They want where g is greater than 0. So these are values that are what than 60 degrees, however. Look at where they are pointing towards. These are values that are less than 60 degrees. But I can't just say less than 60 degrees now. The reason why I can't just say, oh, it's less than 60 degrees and we're done, is because, do you notice that you have a domain here? You have a restriction. If I say less than 60 degrees, it means I can continue going. I can go to negative 100, negative 120. But the graph does not tell me that I can do that. It says strictly that I have to follow these restrictions. Okay. So in terms of this graph and its domain, it would stop at negative 90 degrees. This is the last place that this graph will have a y value greater than 0. So this is really how I'm going to have to say it. Of course, x is less than 60 degrees, but it also has to be greater than negative 90 degrees. But then I also have to consider at negative 90 degrees, right? At negative 90 degrees itself, does the graph of g have a y value greater than 0? So look at the y value of it at negative 90 degrees. It is 1. So it does have a y value greater than 0. So in my solution, this is what I'll say. Since I can see that it's going from negative 90 to 60, I will say that x has to be greater than or equal to negative 90 degrees. It's equal to negative 90 degrees because at negative 90 degrees, we have a y value that is greater than 0. Okay, we have a y value of 1. So x is greater or equal to negative 90 degrees. So it's everything going like this, but less than 60 degrees. And I'm not going to say less than or equal to 60 degrees because at 60 degrees, as you can see, we have an x-intercept. At 60 degrees, the y value of this graph is 0. They don't want where it's equal to 0. They want where it's just greater than 0. So I cannot take 60 degrees as the physical x value. Okay, so this will be my solution. X needs to be greater or equal to negative 90 degrees, but less than 60 degrees. Now, 6.4.2 says we have to determine again the values of x for which f of x is greater than or equal to g of x. So with this one, what I would like to start with is find out first where exactly is f of x equal to g of x. Then I'll start from there. So let's look at the graphs. Where is f of x equal to g of x? It would be at their point of intersection, because at the point of intersection, the two graphs have the exact same y value. That's what f of x is equal to g of x really means. Okay. But of course, we're going to solve for where it is greater than or equal to. So at least I know now where they have the same y value is at this x value, which they gave us. They gave us the x value and they gave us the y value of this point of intersection, which is m. Okay, so we know where they're equal. But where is f of x now going to be greater than g of x? See it like this. If f of x is greater than g of x, it just means that the y values of f must be bigger than the y values of g. In other words, the graph of f in here, right, in this diagram, needs to be above the graph of g. So we have to look for places where we notice that f is higher than g. Okay, so this is what I'm looking for. I'm looking at it and I'm noticing that here, look at this. This is the graph of f. I'm noticing that here, the graph is higher than g. And I also see that they also intersect here as well. Okay, so there's another point of intersection, but we can clearly see that point. That's great. It's negative 30 degrees. Okay, so that's a place it intersects, and we can also see that between these, the graph of f is greater than the graph of g. Okay, it's above the graph of g. Okay, question 6.4.2 says we need to determine the values of x such that f of x is greater than or equal to g of x. Okay, so let's look for that. Okay, so when we get these types of questions where you're looking at two graphs and one is greater or equal to the other one, you have to, first of all, it will be best to start by looking for the places where they are going to be equal to each other. Okay, so I'm going to find the places where they will intersect, because when the y values are equal to each other, it means that they are intersecting at that point, meaning they have the same y value and the same x value. Okay, so I'm going to look through and see where the places they intersect. If I look through, I see that they intersect here, and the x value they intersect at is negative 30 degrees. And where else do they intersect? They intersect here as well. And they've already made that clear for us at least. They told us that the x value of that point where they intersect is here at 48.05 degrees. Okay, so we have a reference. We have references for both of them. Now, they want to specifically know where f of x is greater than or equal to g of x. We've already found where they are equal. So we need to now find out where f of x is going to be greater than g of x. Remember that f of x and g of x, they stand for the y values of these graphs. So we're just looking for where the y values of f is greater than the y values of g. In other words, on this graph, we're going to look for places where the graph of f is going to be higher or above the graph of g. Okay, so to make this easier, I've highlighted the graph of f in red and the graph of g in blue. So we already know where they intersect, but we just need to see where the places where the graph of f is higher than the graph of g. Okay, so the graph of f is the red graph. Where is the red graph above the blue graph? It's definitely not here, because here, you see, blue is above red. Not here, blue is still above red. But then here, look what happens here at this point. You see now that the red graph, f, is above the graph of g, all through here. So all through this region here. So we're going to be able to answer them. You see that nothing happens on this side here. Okay, it doesn't happen here. So our answer and how we're going to answer them is like this. As we can see that this is clearly happening starting at 48.05 degrees. And if we move to the right of this angle, it keeps happening. See, it's above the graph of g, keeps being above. So it means that our answer, we're just saying that x needs to be greater than or equal to. You see, you have to say equal to, because at this point, 48.05 degrees, the graphs intersect. We want to know where this graph is greater than g of x, but we also want to know where they are equal. And at this point, they're equal. So 48.05 degrees. But what is it less than? Because I can't just say it's greater than that and it just keeps on going. It stops because of our domain. So it stops at 180 degrees. You can't go beyond this. So I have to say, but less than 180 degrees. And I'm not going to say less than or equal to 180 degrees, because at 180 degrees, the graphs don't intersect. Okay, so it's really between these two. So where it's greater than this, but less than 180 degrees. Again, that would be our answer for that question. Okay, so that's the answer for this part really. But remember, we need to make sure that we answer the question in full, right? This is where, it is greater or equal to here. But we still cannot ignore the negative 30 degrees. Though we cannot find places where f is above g in this region, we do know where f is equal to g in this region. And that is at negative 30 degrees. So I have to also say, or x is equal to negative 30 degrees. Okay, so that's going to be my answer. So I'm going to just write that down. Okay, so moving on to the next question. The next question says, again, we have to determine the values of x such that f of x is multiplied by g of x is going to be less than 0. So f of x times g of x needs to be less than 0. Okay, so at least they didn't say less than or equal to. So we don't really have to consider those ones. It just has to be less than 0. So let's think about it like this. If you are multiplying two y values, two numbers, you want to get a value that is less than 0. The only way this will be possible is if f, for example, is positive, and when you multiply it by g, let's say is negative, then it will give you a negative value, which is a value less than 0. Okay, so we need to look for where is f going to have negative y values and where is f going to have positive y values and g have negative y values at the same time. Now, this is not the only way that we can multiply them and then give us a value less than 0. If f as well, right, was negative, and we multiplied it by g, which was positive, then it will also give us a value less than 0. So this is really the requirements we're looking for. We're looking for where f and g, where f is positive and g is negative at the same time, where f is negative and g is positive at the same time. So I'm going to snip this to the side of the screen so that we can go ahead and answer that question using the graphs. Okay, so I'll start by looking at f. Where does f have y values greater than 0? Okay, where the graph of f would have y values greater than 0 are all the places that it lies above the x-axis. Now, because of the way this graph has been shifted, you notice that it kind of always lies above the x-axis, except for places like, the x-intercepts that we have like 30 degrees and negative 90 degrees. Then technically at that point, it doesn't have a y value that is greater than 0. It has a y value that is equal to 0. So I'm looking at it like this. Look at all the places where f is positive. Okay, these are all the places where f has a positive y value. But we need to find the graph of g having a negative y value at the same time or for the same x values. Okay, if you look at the graph of g within this region here, where we have the graph of f having positive y values, you see that if we're looking at it for the same x values, do you see that the graph of g is also positive? So that's not what they're asking for. They don't want this. They don't want where both graphs have positive y values. They want where one's going to be positive and the other's going to be negative. But as you can see, the graph of f is just never going to be negative. So I'm even looking at the second scenario and I know it's not going to work out at all. The second scenario won't even exist. So what I'm saying is it's not working out here, okay? Because here, g has a positive y value. F also has, a y value of 0. Then if I move a little higher than that, if I move like to this point, f has a positive y value. And if I'm looking at the graph of g for the exact same x value, it has a positive. That's not what I want. I want it to be positive and negative, but they're both positive. So you will see that that continues all the way through. Here, it keeps having positive and positive. Still positive and positive. Still positive and positive. Okay, all the way through. But then when we get to this point, let's look at this. You see when the graph of g goes past the x-axis now, look at what happens starting from 60 degrees. You see the y value of the graph of f at 60 degrees is 1. But I can't necessarily take this point exactly. The reason why is because we are multiplying both graphs, remember. We need to multiply the y values and they need to give us a value less than 0. Okay, if you multiply the y value of g, the y value of g here, is 0. If you say 0 times 1, it will give you 0. They don't want a y value of 0. They want a y value less than 0. So this is a starting point, yes. It may not be 60 degrees exactly, but it is a starting point. So what I'm going to highlight now is this. In the graph of g, I notice that it's actually working through here. Look at this part. See, the graph of g has negative y values all through here. So if we're looking at it look at the x values of this graph. That x value, right? The y value of f is positive and the y value of g is negative. That's what we want. We want that when you multiply their y values, they would give you a negative number. So it's working here. It's working here. It keeps working because this one keeps staying positive. It keeps working. But I also now notice that the minute I get to 150 degrees, it's not going to work here. And here's why I'm saying so. Let me even highlight the places I'm saying it's not going to work at that point. Okay, 60 degrees is not going to work because the graph of G itself at 60 degrees, the graph of G has a y value of 0. Likewise, that's the same thing, a similar thing going on with the graph here at 150 degrees. Do you notice that at 150 degrees, the graph of F has a y value of 0? If you multiply its y value of 0 with the y value of G here of -2, you're not going to get a negative number. 0 times -2 is 0, not a negative number. We want a value that is less than 0, that is negative. So it won't work at 150 degrees, but it is working still here. So if we go greater than 150, we'll also see that it's working here and here. Here, the y values, okay, the y value here is positive. And for the same x value, the y value is negative. So it's working all through there. So these are the places that it's actually working. We can now answer them like this. We can say that we notice that it worked from 60 degrees going all the way to 150 degrees, okay, but not exactly at 150 degrees. And then it also works when you move greater than 150. So I would actually say here that x is just greater than 60 degrees. But, and you see, I'm not saying equal to 60. I'm saying greater than 60, not greater or equal to, because at 60 degrees, you have the G graph having a y value of 0. And then I'm also going to say, but x must not also be equal to 150 degrees exactly, right? It mustn't be equal to 150 because at 150, again, you have your graph of F having a y value of 0. If it multiplies by the y value of G at that same x value, it's going to give you 0 and not something less than 0. So this would be your answer. X is greater than 60 degrees, but x must not be equal to 150 degrees. And now I'm seeing that I actually have to tweak this a bit. This is not going to be accurate. If I just say x is greater than 60 degrees, it means I'm saying that this thing can continue going on. And it can't. It's going to stop at 180 degrees because of our domain, that restriction. So let me just tweak this. I'm actually supposed to say x is greater than 60 degrees, but less than 180 degrees. It mustn't go past 180 degrees. And x also must just not be equal to 150 degrees. Okay, so that is a better way to say it. Okay, so that is our answer there, and we can move on. But then at 180 degrees, you see, you should always be checking if it's just less than 180 and not equal to 180. At 180 degrees, if we look at the y value of G there, okay, the y value of F, is, it's going to be 1, right? That's 1. If you take that y value of 1 and you multiply it by the y value of G, and the y value of G is negative something. I don't know what it is exactly, but it's negative something. By a negative number, it's still going to give you a negative number. So in fact, at 180 degrees, I have to say less than or equal to 180 degrees because at 180 degrees, this works as well. Okay, if I just say less than 180 degrees, I'm saying that it can't be equal to 180 degrees, that it's just everything less than 180. And that's not really true. At 180 degrees, this is still being met. This requirement is still being met. So I need to include that. So in a nutshell, this would be the answer. Okay, x is just greater than 60 degrees, but less than or equal to 180 degrees, but x must not be equal to 150 degrees. Okay, so question 7 says, a camera person is stationed at the top of a vertical tower, okay, TG, and TG is equal to H. She films a cat starting at A. So she's filming this cat starting at A, where the angle of depression of T after A is theta. Okay, so here's our angle of depression. The camera follows the cat as it walks in the same vertical plane. So as this cat is walking here, this camera is following. So the camera is basically just going to be moving like that. You know, the lens is going to be moving like that. Okay, and then they say that in the same vertical plane, a distance of x meters horizontally to B, creating the angle of beta. Okay, so just moving like that. The cat is moving till this point, and because of that movement, when the camera is here, okay, watching the cat, the camera basically curves like that and creates this angle beta. Okay. Okay, so all we can see here is we've just got shapes, okay? We have a right angle triangle. We've got this triangle over here, an obtuse angle triangle. This is theta, beta, and this is x, and that is h, okay? So those are just the things they've given. They don't seem to have given us any numbers really, just, angles. That's all. The first question is we need to determine angle B in terms of theta and beta. Okay, so angle B in terms of B1 really, in terms of theta and beta. Okay, so we just have to find angle B1 in terms of alpha and beta. So how does alpha and beta relate to angle B1? Well, I'm seeing that you see this line over here. It is a flat horizontal line. And what is also a flat horizontal line is this line GA. It's also a flat horizontal line. So we have a line going through like this. Okay. And since these two are flat horizontal lines, it means that they're actually parallel to each other. So what kind of angles do you find on parallel lines? You find fun angles. And I can see that if I draw a Z here, okay, I have alternate angles. So that would mean that this entire angle is equal to angle B1. So how we find B1 is we just say that angle B1 is actually equal to this entire angle, which is made up of theta plus beta. So there, it's theta plus beta. That is angle B1 in terms of alpha, theta and beta. I keep saying alpha. In terms of theta and beta. Okay, moving on to the next question. The next question says, show that x is equal to h sine beta over sine of theta plus beta over sine of theta. Do not worry too much about the way this looks. You're not trying to force it to look like this. All they're really asking you for is to find x. So that's what we're going to concentrate on. Now remember, the previous question is going to have a lot to do with the next question. So let's look at x. X is over here. We're going to ask ourselves, how can we actually find x using everything we have right now? Okay, so one thing I notice is, now this is where you actually do look at these. One thing I notice is that h is also part of what they're speaking about here. H is part of it. I also just realized that if I can find this length over here, right, which I can using this right angle triangle. If I can find this length over here, and then if I can find the entire length of AG, that entire length, I could take the big length of AG minus the length of BG, and it will give me X, which is AB. Okay, so that's the what I'm going to go with. I'm going to try and see if this works out. So, okay, let's see. How do I first find? So I'm going to find first of all AG. I can find AG if I use this right angle triangle. This huge right angle triangle, I can use that to find AG. Okay. But now in order to use this, I have a side, that's great. And I'm looking for AG. I need to have an angle. So at least one angle, and it can help me. So if I can find this angle over here. If I have this angle, I can use the fact that this angle, right, has a side opposite it, and it has an adjacent side as well. So I can use opposite over adjacent, which is tan. I can use the function tan to actually find the length of this. It won't be a number, of course. Okay, so that's what I'm going to do. So first of all, I need to find this angle. What exactly is that angle? To find that angle, why don't we just use the fact that we have two parallel lines again? This is parallel to this. So why don't I just say, here's our alternate angles. So it means that theta is equal to that angle over there. So that's what I'll put down first. I'm going to tell them that this angle A, and I can call it angle A. There's no confusion. It's not like this one. I can't call this angle B. I have to call it B2. Okay. So angle A, I can say angle A, first of all, is equal to theta. Okay, so I have that down. I know that this is theta now. And now that I know that that is theta, I can now go ahead and try and find AG. Okay, so to find AG, like I said, I'm going to use this big triangle, and I'm saying this is the opposite side over the adjacent side. So I'm going to have to use the function tan. So I'm saying tan theta is going to be equal to the opposite side, which is h, right, over the adjacent side, which is what I'm looking for, AG, which is AG. Let me even put it in red so I remember. And now in this equation, I just have to make AG the subject, because remember, I'm just trying to find AG, then find BG, and that will help me to find this X over here. So I'm going to try and make AG the subject of the formula. You can do that by multiplying both sides by AG, because I need to get it out of the denominator. So AG and AG. And so now I would just have AG tan of theta is equal to H, because the AG cancels here. And then I can just divide both sides by AG. And if I divide both sides by, sorry, not AG. If I divide both sides by tan theta, because I want to make AG the subject, divide both sides by tan of theta, it means that AG is finally just equal to H over tan of theta. Okay, so I have something for AG, and that's great. Now that I have something for AG, what can I do with this? I'm going to use, I found AG, I just need BG now. So if I can find BG, I will be able to find AG. So now my focus is here. Now in BG, which triangle is BG part of? It's going to be part of this triangle, TBG, that triangle. And so what I can use in this triangle is this reference angle that we found already earlier. And I can also use H to find it. So I'm saying it's again the opposite side I'm using over the adjacent side, since this is what I'm looking for. So you need to include something that has already been given, like something that already has a value, and the thing that you're looking for. So again, opposite of adjacent is tan. So I'm going to use tan again there. So I'm just continuing from this side. I'm going to say tan of, this time not theta, but theta plus b. So theta plus beta is equal to, it's the opposite, which is H, over the adjacent, which is GB. So H over GB. And again, I just want to make GB the subject. And I'll put that in blue so that I know that that's what I'm looking for. Okay, again, to get GB on its own, you would multiply both sides by GB. But look at another way that you can see that. You can see it as taking GB over. When you take GB over, because it's being divided, okay, when it goes over, it's going to be multiplied to this. So it's going to have, we're going to have GB on top here. And then, of course, the tan theta and stuff. But now I decide that I want GB to be left on its own. So I took GB over. Because I want GB to stay here alone, I'm going to take the tan over. When you take the tan over, in this case, you know what? It's fine. Let's rather just do it the normal way. So it's like multiplying both sides by GB. It's that I can do it like that, but I don't want to now confuse anybody on that. So GB tan of theta plus beta is equal to, and that cancels and we have H. Then again, we just divide both sides by tan. Theta plus beta, divide by tan, theta plus beta. And now we know that finally GB is actually just going to be equal to H over tan of theta plus beta. Okay, so that's what GB is, and that's great. We have GB. We're going to use that now to find AB. Okay, so do you see that AB is made up of, or really GA is made up of GB plus the line BA, which is what we're looking for. And so in order to find it, we're just going to say the line AG minus the line BG. Then we will be left with AB. Okay, so that's what I'm going to say there. So therefore, I'm just saying that AB is equal to GB minus AG. That's all we're going to do. Okay, minus AG. Why did I say AG? Sorry about that. I meant AB is equal to AG minus BG. Okay. Okay, so this is what we have. Remember, this is GB is the same thing as BG. Okay. So X is AB. That's what we're looking for. So I can therefore say, therefore it means that X is actually equal to, and what is AG? It's H over tan theta. So H over tan theta minus BG, which is H over tan of theta plus beta. And now we just have to find a way to simplify this. Okay, at this point, because I just started to simplify it further, I'm starting to realize that this method may not work too well, because simplifying this actually is turning out to be harder than what it looked like. So, and I also noticed that I'm seeing sine here, but I'm not seeing it here. So I'm seeing another way that we can actually work this out. Instead of doing that, look at what we can do instead. So instead of using this whole minusing those lengths, what we could do instead is this. How about, because they told us to find this, you see, the next question usually has a lot to do with the previous question. Since they asked us to find this at first, how about we use this triangle over here? Okay, because the thing is, I focus on this triangle only because I noticed that, okay, it's a triangle that has x in it. So I want to use this triangle. And if you see this triangle, it's actually somewhat complete. It has theta over here, right? And then opposite it has beta. Now, do you notice that beta is right opposite x, right? So I'm seeing the sine rule. We can actually use the sine rule here. As long as, because now we see that we also have theta here, and theta is right opposite this line BT. So if only we can find the length of BT, okay, in terms of course, H or whatever it's going to be in terms of, we can find BT first, and then we can use the sine rule. So we have an angle, we have the side opposite it, we also have an angle here and the side opposite it. Okay, and then we'll just make X the subject. And that one will have sine in it. So I'm going to go for that instead. Okay, let's go ahead and try that. Okay, so I'm still leaving that angle A is equal to theta. I'm still going to leave that there. But with this one, what now we're going to do is, let's go ahead and find BT first. To find BT, this won't be so bad because we have in this triangle, the right angle triangle here, we have H as an opposite side. So we can see it as we're using the opposite side, but because we also want BT, BT is the hypotenuse of this triangle. So we're going to have to use the opposite and the hypotenuse. So think about it, opposite and hypotenuse. Which function can you use here? You can use sine. So we can say sine of this angle, reference angle, theta plus beta, is equal to the opposite, which is H, over the hypotenuse, BT. So let's go ahead and do that. So we're saying sine of theta plus beta is equal to H over BT. And now all we have to do is make BT the subject of the formula so that we can use it in this next triangle using the sine rule, of course. So I'm going to say that we're going to take BT over by multiplying both sides by BT. And so here we just have, of course, BT sine of theta plus beta, still exactly the same. And on the right-hand side, BT would just cancel. And we are left with H. And so we need to solve for BT, so we can divide both sides by sine of theta plus beta. And so finally, BT is going to be equal to BT is equal to H over sine of theta plus beta. Okay, so we have BT now. Now we can use that. And you see H over sine theta plus beta, there we kind of have that. That's H sine theta plus beta. Okay, now that we have BT, I'm done with this yellow triangle and I'm going to focus on this now. I'm saying that I want to find the value of X. So in this case, because you want to find a length, remember the sine formula works like this. You can say sine of angle A, but then you must say over the side that is opposite A, which is BT. But you can also start by saying BT, a side, right, over sine of angle A. You can work with it like that. So because I'm looking for X, I'm going to start with AB over, okay, so that length over what angle? Over the angle that is opposite it, okay, over sine of beta, which would be equal to, now I need to take another two pair of side and an angle that is available. So since I'm taking these two together, The other one that is available is BT, which we just found. So I'm saying BT over the angle opposite BT. The angle opposite BT is theta. So sine of theta. Okay. And honestly, with these, I should just really be putting the lengths that it has. Like AB has X. Okay. So I can just call that X over sine beta, and BT has what it has, which I'll substitute in. So let me write this down. Okay, so we have this now, and I'm going to substitute BT, which is all of this. So what I'm saying is X over sine of beta, but I also remember that BT is a fraction. So I can actually just start by saying BT, which is H over sine of theta plus beta, and I'm saying it has to go over sine of theta. Another way of saying over sine of theta is divided by sine of theta. So I'm actually going to use the division sine of theta. Then we'll simplify that further. So you see here, we're just trying to solve for x. That's all we're doing here. Okay, let's just sort this part out first. So we just still have x over sine of beta. Let me just write properly here. X over the sine of angle beta. And then we have h over, still stays the same, sine theta plus beta. But now when you're dividing, okay, you're dividing a fraction by something that's not a fraction. First of all, make it a fraction by putting it over 1. Then when you're dividing, there's a rule called tip and times. This works with division of fractions, okay? When there's a fraction and you're dividing, you're going to tip this one, meaning swap its numerator and its denominator. So it becomes 1 over sine theta. And then you're going to times. So you're going to change the division into a multiplication. Okay, so this is what we're going to have here. I still have x over sine of beta, and then it's equal to, it's going to be, so here we're multiplying these two fractions. When you multiply fractions, it's numerator times numerator and denominator times denominator. So that's going to be h over, and we have sine of theta plus beta, and it's being multiplied by this. So because they are just variables, they just stick together like that. That's what we have. And now lastly, just to solve for x, all we have to do is get x on its own by removing this. You see, this thing is dividing. It's dividing into the x. So to get rid of it, you have to multiply both sides by that sine of beta so that it falls away. So times sine of beta. And so x is equal to, and look what happens. We have a numerator times a numerator. Remember, the denominator here is by default 1. So h times sine of beta is h sine beta over, and of course this times 1 will just stay the same. So sine of theta plus beta, and we have sine theta. Okay, and that is the value of x. So the reason I just decided I'm not going to cut that whole mistake out is just so that you can see the thought process. It's not that we just look at it and know, okay, this works out. Sometimes you work through it and you start seeing there may be another way, and then you just try to look at how to get to that answer in a different way. So as you can see, it is the same as what we have here, and so we know that answer is correct. Okay, moving on to the next question. Okay, so the next question says, determine the distance, which is x, the cat walked from A to B if the tower was 20 meters high and theta is equal to 65 degrees. So 20 meters high, theta 65 degrees, and beta is 37 degrees. So they just want us to find the value of x. And they're telling us the length of the tower. Remember, the tower was this part. They told us that this tower TG is equal to h. So that's h that they're speaking about. So they're giving us everything and we just need to solve for x. So just substitute. Our equation was x is equal to, and we had h, right? We now know that h is 20 meters high. That's the length of the tower, the height of the tower. So that is 20 multiplied by sine of beta, and beta is 37 degrees. 37 degrees over, and we have sine of theta plus beta. So theta is 65 degrees, 65 plus 37 degrees, and then sine of theta, which is 65 degrees. Okay, so just substitute and we get our answer. Okay, so the answer that we get is x is equal to 13.58, okay? And x it's a length. It is the distance that the cat walked. Okay, since it was a length and everything here, we just have to see what it's been measured in. Everything here, because this is in meters, 20 meters high, then this is also in meters. Everything there is in meters. So there we go. That is our answer. So that is the end of question 7. And then we move on to question 8. Okay, so we're on question 8, and question 8 says, figure A below, so this one, shows a rainwater gorge. Okay, apparently that word is actually gauge, not gorge. It's actually gauge. So the figure below shows a rainwater gauge in the shape of a cone. Okay, the level of water is indicated with a diameter of 18 centimeters. So they're just saying this is the level of water. This is how high it is. Okay. Of course, it's not 18 centimeters high, but the rim, okay, round about this radius, round about this diameter, okay, that is 18 centimeters. That's how far we can see the diameter of that is. Okay, what else did they tell us? Then they tell us that figure B, they tell us the figure B shows the same cone after a steel ball has dropped into the cone. Okay, a steel ball dropped in. The angle of the cone is angle P, which is 28 degrees, with the steel ball having a radius r centimeters. Okay, Q is a point where the ball touches the side of the cone. So there is this gauge, and then we have here, this is how high the water is, and this circle, okay, that rim of where the water is, it has a diameter of 18 centimeters. Then we can also see now that when the steel ball drops, it touches Q. So a lot of Euclid looking things here. And we have this angle as 28 degrees. Then they're also giving us formulas. They give us the formula of the volume. They say that volume is equal to 1 over 3 pi r cubed. And they're also giving us volume here. So they're really just giving us the volume of each shape. The volume of this one, or really not of each shape, but of the contents in the shape, okay? Whatever liquid is here. I think it's water. Yeah, it's water. Rainwater. So this is the formula to calculate the volume of that. And then the volume of this one, of course, after the ball has dropped in. Okay. Now, if you look at both of them, you'll also notice that this one, you just have 1 over 3 and then pi r to the power of 3. This one, you have 4 over 3 pi r to the power of 3. Okay, if you look at 1 over 3 and 4 over 3, which one would you say is bigger? See, they're equivalent fractions, so 4 over 3 would be bigger. And that makes sense because there's a ball now here. It doesn't mean there's more water, but it is higher though now because something has dropped in and it's occupying space, letting the water, of course, rise higher than this one. So since the first question says, determine the volume of rainwater in figure A, we're just going to use that formula for rainwater in figure A. Okay, as you can see, the only thing we need to substitute here is R. They gave us the diameter. The diameter is always going to be twice the radius. Okay, so if you want to find the radius, it's going to be half of this. So our radius, we know, is going to be 9 centimeters. Okay, so let's go ahead and calculate that. Okay, so radius is 9 centimeters, and we're just saying the volume is equal to 1 over 3 pi times our radius to the power of 3. So our volume is going to be in centimeters. We can just put that in. Okay, and the volume is 763.41, and I'm going to keep this as centimeters cubed because volume is always in cubed. Area is in squared. So that is the first question. Moving on to the next question. Okay, so the next question, 8.2, says the volume of rainwater in figure B is increased by 268.08 centimeters cubed when the steel ball is placed inside the cone. Okay, so remember, technically, it's not being increased. Like, it's just a ball falling inside. So what I'm trying to say there is they didn't mention anything about more water falling inside this cone. But I'm just looking at it from a logical perspective. We need to look at it from what they are saying. If they said that the water there increased, we're gonna follow that. Okay, the water there increased. But logically speaking, the water is it's not really increasing. It's just a ball falling inside, taking up more space, and so the water naturally goes higher. Okay, but we're gonna follow what they're saying. So since they said the rainwater in figure B is increased by this when the steel ball is placed inside the cone. Okay, now we need to determine the length of PQ. Okay, to find PQ, what you need to do is we're going to have to look at PQ and just construct a way to find it. We're also going to have to look at what they gave us and see what we can actually do with that. First of all, they told us that this water, right, the rainwater in figure B, the volume of this thing, it was increased by this. So it means that the total volume, we can calculate the entire water that is in here. Since the one in figure A was, that 763.41, this one is going to be 763.41 plus, okay, the thing that has been increased by, which is 268.08, okay, plus 268.08. So that will tell us the entire volume, okay, of the water in figure B. So that's what I'm going to do first. I'm going to go ahead and add them together. So I'm saying that the volume, of course, in figure B, you don't have to do that. I'm just doing that because I don't want to mix it up. But it's fine. I'm talking about the volume of figure B. That it's going to be 763.41 plus 268.08. And we can just add that up first. And we get 1031.49. And this is, of course, in centimeters cubed. So that is the total volume in figure B. That's what we're saying is now here. Now, what can we do with that? What can we do with that number that we just found? Which is this, of course, okay? What can we do with that? Well, we have the calculation for the volume of this. And we have the actual volume of it. So what we can do is say that the volume, okay, substitute the volume here because this is the volume of this, according to them. This is the volume. So we can substitute it into this formula. And as you can see, the only thing missing in this formula is R. It will help us to find the value of R. So let's go ahead and do that. So I'm saying that the volume that they gave us there, V of this this figure B, is 4 over 3 pi R cubed. So 4 over 3 pi R cubed. But now I know the volume of figure B. It's this. So I'm going to substitute that in place of volume. So 1031.49. 1031.49. I know that already. So it's 4 over 3 pi R cubed. And now all I will do here is I can see that this will help me to solve for R because it's the only variable here. Pi is a number. Okay. So how do I get R cubed right now? Because the cube is with the R. How do I get R cubed on its own? I'd have to get rid of 4 over 3 pi. And do you see that 4 over 3 pi? They've been multiplied to R to the power of 3. So if you divided both sides of the equation by 4 over 3 pi and 4 over 3 pi, it would cancel that out. And so we'll be left with this number. I'm not going to write it down because I don't like decimals. We're just going to leave it like this for now. And pi is equal to R to the power of 3. Okay. And now we just need to solve for to solve for R, we need to get rid of the cubed. So we will cube root both sides. Cube root and cube root. Okay, so R is finally equal to, and now we can just put that all onto the calculator. So I'll put it on like this. I'm going to first find the cube root by pressing on your calculator. Okay, mine is also fine. So shift and then that for cube root. Now I'm going to put a fraction and on top I put 1031.49 all over, I'm saying 3 over 4, which is of course being multiplied by pi. So shift and pi there. Okay, so that's what we get. I leave it as a, this is weird now. I don't know. Should I round off? I don't think I'm supposed to round off though. Maybe I should just leave it like that. Okay, no problem. I'm not going to round off, but I'm going to write the number down. I'm going to say it's 7.593, and I just want to be exact with it. So when I need to use R again, I will use that ans button. Also, I do have this here, so I could still make use of that. So I'll use the ans button. Okay, so we found R. How is this helpful? To find what they asked us to find, the length of PQ. Okay, we need the length of PQ. This looks like Euclid. So PQ, to find PQ, and we have R now. How can we find? And they also gave us this as 28 degrees. Okay, we can draw another radius because the radius goes from the center to the circumference. Just to make you see what's going on here. If you had another radius here and another point, of course, let's say this was just for the sake of understanding A, right? AP would be exactly equal to PQ because in Euclid we learned that tangents, okay, drawn from the same point would be equal. So because they're equal, what I'm just trying to show you is that I can actually draw a line that's going to come through here like this. And this line is going to bisect that angle 28 degrees. Okay, emphasis on the word bisect. And the reason we know it bisects, because technically what we're doing is we have, if you joined A and Q, right? You'd have a straight line. And you see that A, right? This midpoint is still in line with the center of the circle. That's what even makes it a midpoint. So you're just drawing a line from the midpoint and it's going to bisect this angle. So it means now this part is going to be half of 28 degrees, which is 14 degrees. So I have 14 degrees over here, and now I'm not going to use that. I have a right angle triangle. Okay, now why am I saying it's right angle? Because if you have a radius and you have a tangent, Euclid also says that the radius is always perpendicular to the tangent at the point of contact. It's like they're already giving you a preview of Euclid, even though you haven't really gone through that yet. You still have to go through it in question 9, okay? So this is what we have. Since we have this, how can we use this to now find R? Okay, this looks simpler now because we just need to find, we have R. How can we use this to find PQ? Okay, how can we find PQ? Well, we can find PQ using trigonometry now. Since we have an angle, we're looking for PQ and we have R. Let's look at what the sides are in relation to the angle. First of all, 14 degrees, R is opposite 14 degrees. And then PQ is next to it, so it's the adjacent. So we have an opposite side and an adjacent side. So we're going to use the function tan. Okay, so I'm just going to first of all state that I have this angle. I don't even know what to call it because they didn't even name this. I guess if you use it in your calculation, they will see that you did find that. So I'm just going to say, I need to say tan of 14 degrees is equal to the opposite over the adjacent, which is our R value over PQ. And so we have R, we'll substitute that there and we'll be able to find PQ. Okay, so this is what we have. And now we can go ahead and I'm not going to substitute R yet. I'm going to make PQ the subject first. So if you multiply both sides by PQ, which I'm not even going to do that anymore, I'm going to actually just take PQ over. And so it goes to the numerator because it was on the denominator. And I'm going to take tan of 14 degrees over and it's going to go on the denominator because it's naturally on the numerator. You can go ahead and do that whole method of multiplying both sides by PQ and then making PQ the subject. Okay, is equal to R over tan of 14 degrees. And now I'm just going to substitute R. So PQ is finally equal to, and I'll use the button ant so that it is on the dot because I can't round off here. This is not the final answer. They asked for PQ. Okay, so that's 93 point and then keeps going divided by tan of 14 degrees. So PQ is finally equal to, and I'll just substitute that into the calculator. So here on the calculator, I'm just going to say as a fraction, I'm putting ants and then over tan of 14. So tan of 14 degrees and let's see what we get. Okay, we get PQ is 30 point and in decimal form PQ is equal to 30.0 0.45 rounded off to 2 decimals because 4 is less and it rounds down. So this is, again, remember, in centimeters since the volume was in centimeters cubed. So this is in centimeters. And there we go. Okay, so we're on question 9, and question 9 says, in the diagram, chord FD is drawn in a circle with center O and FM being equal to MD. And they want you to use the diagram on the attached answer sheet C to complete the proof of the theorem, which states that the line drawn from the center of the circle to the midpoint of a chord will be perpendicular to that chord. That is proof that OM is perpendicular to FD. So you have to prove that that is perpendicular. Okay. And they've made this very simple by actually filling in a lot of things, and then you just have to fill in the missing things. Okay, so first of all, they do mention that you have to speak about the constructions that have to be made. Please also do remember, I do have these proofs as well on my channel. If you just go there and you look at the videos, if you scroll down, it's like one of the first videos that I made on the proofs of circle theorems and also some grade 12 Euclid proofs as well. Okay, so this is what we have. The construction that has to be made is this. You have to construct a line, okay, from O to F. So you have to construct line OF and line OD. Those are the constructions. So construction, I'll just say line OF and OD. That's all we need to construct. And then they say, they're already naming the triangles for you. In triangle OFM, and triangle ODM, that what you have to do is, first of all, they're telling you that FM is equal to MD. FM is equal to MD. That has already been given. We didn't do anything about that. That was already given, and that's completed for you. The second thing is OM is a common side. Okay. So that has already been completed for you. Normally we would say OM is equal to OM, and then the reason would be common side. Okay, but they've already completed it for you. And then lastly, OF is equal to OD. So why is OF equal to OD? That's the only thing they're asking for. What's your reason there? We constructed it, sure, but why are they equal? You notice that OF is going from the center to the circumference. OD is also going from the center to the circumference. So what are those lines called? They are radiuses or radii, okay, in plural. So they are equal because they are radii. That's the reason there. You can just say radii. If you like equal radii or radii is still fine. And there we go. So triangle OFM is now congruent to triangle ODM. And the reason for that is you just have to look at the things that we have, like the sides, the angles. First of all, we had an equal side. So that's just a side. Okay, that's a side that we have. And we had OM being equal to OM, which is a common side. It's another side that we have. Okay, that's also just a side. And what else was equal? We had two other sides being equal. The radii being equal. So that's also just a side. Okay, so there, because three sides were equal. So I can just say the reason for that is going to be side, side, side. Okay. And so they're now going to be congruent. Okay, so then we're not done yet because remember, we're just trying to prove that these two are going to be 90 degrees really, that OM is perpendicular to FD. Just because now this triangle is congruent and all the corresponding sides are equal. That means this angle is equal to this angle, and even this angle is equal to that angle, and these two angles also, right, are equal. Just because they are equal, we can't just assume that they are 90 degrees. We have to show them that they actually are 90 degrees. And this is how we're doing this. Here, do you see that they're saying, but angle M1, and this should have been a plus, angle M1 plus angle M2 is equal to 180 degrees. Now, look at that. Why would angle M1 plus angle M2 be equal to 180 degrees? Because these are angles that lie on a straight line. Okay, so there, I think they didn't even want us to give the reason. They completed it. And then they said, therefore, angle M1, because they add up to 180 degrees, and because these two triangles are congruent, right? So it means that all their corresponding sides and angles are equal, including M1 and M2. We knew that they are now equal to each other, but we didn't know that they were equal to 90 degrees yet. We just proved that, or they just proved that, by saying that angle M1 plus angle M2 must give you 180 degrees because they lie on a straight line. And so because those two angles are equal and they also add up to 180 degrees, then it must mean that they are individually equal to 90 degrees. That's the only way they could add up to 180 degrees, since they are equal. So this was already proven for you. So they just said, therefore, OM is perpendicular to FD. Okay, so that was an easy one because they filled in most of the things. We just had to fill in a few things. Okay, moving on to the next question. Next question, 9.2. This is what we have. So 9.2 says, the points S, Q, R, and P lie on the circumference of the circle with center O. Then they tell us that SR bisects chord PQ. Take that very seriously, bisect. So it cuts this chord into two equal parts. Okay, and then at M, and so PR and RQ are joined, and then angle R1 is equal to 62 degrees. Okay, PR and RQ. Okay, they just join here. So because, of course, SR is bisecting this line PQ, it means that PM is equal to MQ. Okay, so this is all we have in this diagram. Let's go ahead and see the questions. Calculate with reasons the values of the following angles. And the first one we need to find is angle M2. Okay, the only angle that they gave us right now is that 62 degrees. So let's see how that can help us to find angle M2. Okay, M2 is over here, right? Now M2, look at how we can actually find it. You don't even need this angle. You know that this line, right, is running from the center of the circle to this chord. And so, do you see that this is the first theorem in Euclid? Because you're already given that PM is equal to MQ. This is the theorem we just proved. PM is equal to MQ, right? And O is the center of the circle. So it means that OM must therefore be perpendicular to PQ. So I'm going to first state that. I'm going to say in that first question that they are perpendicular. Okay, so that is that OM is perpendicular, first of all, to PQ. Okay, and so since it is perpendicular to PQ, look what's going on. Okay, I have to give a reason, sorry. I have to give a reason. This is because the line from the center of the circle, okay, line from the center of the circle to the midpoint of the chord is perpendicular to the chord. So this is the converse of the first theorem. Okay, be careful to know the difference between the first theorem and its converse. The first theorem, because remember, this is kind of like a revision paper. I'm just trying to do revision with you guys. So this is O as the center. You have a chord, and this is AB, right? If we were given this situation where they were already perpendicular, let's just call that M, right? What we can conclude from this one, so look at what we've been given here. Here, all we have been given is that OM is already perpendicular to AB. What you would conclude is that AM is therefore equal to MB. Okay, this is because of the first theorem, which states that a line from the center of the circle, okay, sorry, let me say that again. The line from the center of the circle perpendicular to the chord bisects the chord. Okay, that's the first theorem. Okay, so please just remember that is the line from the center of the circle perpendicular to the chord. So this line, we're just describing that line that runs from the center of the circle, which is perpendicular to the chord, that line bisects the chord. And so that's why AM would be equal to MB. Okay, so that's the first theorem. But please do not confuse it with its converse. Its converse theorem is similar to it. It's not the same thing. The converse theorem, you have a chord as well. But the difference between this one is that this chord, they will tell you that AM is already equal to MB. They're already equal. So in this one, what we have already been given is that AM is equal to MB. What we would conclude because of that is that OM is now perpendicular to AB. Do Do you see they're like the opposite of each other, the reverse of each other? Here, this is what we were given, but here, that's what we concluded. Here, this is what we conclude, and there, that's what we were given, okay? Now, the reason for this one is the line from the center of the circle to the midpoint of the chord. This is now called the midpoint since AM is equal to MB. The line from the center of the circle to the midpoint of the chord is perpendicular to the chord. That is the reason for that. Okay. Now, most teachers or most schools really accept like this. If you just say line from the center of the circle to the midpoint, then they know you know the theorem you're speaking about. Okay, because it's going to the midpoint of the chord. And in this one, if you say line from the center of the circle perpendicular to chord, okay, you don't even have to say to the chord. You can just say to chord. Then they know, okay, you're talking about this one. So be careful. They look similar, but one is the converse. This is the converse, and this is the original theorem. That's the original. Okay, so let's just get on with that question. So think about it. I just concluded that OM is perpendicular to PQ. What reason am I going to use here? The line from the center of the circle to the midpoint of the chord, because PM is already equal to MQ. That's going to be our reason here. Okay, so now that I know that that is perpendicular, OM is perpendicular to PQ. So because this is perpendicular, they want M2, okay? If you want to find M2, you can kind of just see it like this. M2 by default is going to be equal to 180 degrees. You can either see it like, because this angle here is already 90 degrees, and if you add it to this angle, it should give you the full angle of a straight line, which is 180. So this must be 90 degrees as well. You can also see it as you have lines crossing here. So if there's 90 degrees here, M2 is vertically opposite that angle. So I would just say angle M2 is equal to 90 degrees, and I'll just say because the angles are vertically opposite. But then again, you technically don't really have to do that. As long as you've shown that this is, perpendicular, it would by default also mean the same for those. So you can just conclude the size of M2. Angle M2 is equal to 90 degrees. Okay. But honestly, I would have just been tempted to say vertically opposite angles, because I'm like, this is not M2 technically, but it's fine. Perpendicular means it's going to be perpendicular on every side like that. So yes, M2 is equal to 90 degrees, and our reason is really because of that. You see, line from the center to the midpoint of the chord is perpendicular to the chord. Okay, moving on to the next question. Okay, so the next question is we need to determine the value of angle Q2 plus angle Q1. Q1 plus Q2. Okay, so let's see how we can do that. Q1 and Q2. Okay, I don't see any tangents, so I can't really use anything about tangents. But I do, however, see this. So I see that you see Q2. It's being supported by this arc called PS. Now we have another angle at the circumference. You see, how you look at these things is, it's not that I just looked at it and saw, oh, angle at the circumference. I mean, those would be equal. I looked at the fact that Q1 and Q2, we have to find that, right? Oh, I see. There's an easy way to solve for this. You don't need to do all of that. Q1 and Q2, there's a reason that they said angle Q1 plus angle Q2. It's weird. Why did they just have to add them together? It probably means that you have to look at those angles as if they're one angle. And look what happens if you do that. If you look at those angles as if they're just one single angle, do you see that these two angles are supported by a diameter? And if you have an angle supported by a diameter in a circle, it means that that angle is equal to 90 degrees. Okay, so that makes sense now why they said Q1 plus Q2. Okay, so you see the thought process. I thought it was something else, but then that step was going to take longer. And then I was like, oh, okay, so that's why they added it together. So we can actually just say that angle Q1 plus angle Q2 is equal to 90 degrees. And it's because of the angle supported by a diameter in a circle, or angle in a semicircle. So I'll just say that angle in a semicircle. Okay, so that is that. And moving on to the next question. Okay, next question, we have to find the size of angle S. Oh, angle S. So we know this is 90. Let me also just put the other things that are already there. We know that that is also 90. They want us to find the size of angle S. Well, if we found angle R2, and we know this already, we can use the angles in the triangle to solve for angle S. So there we go. Let's find R2. And how much marks is this for, by the way? It's 2 marks. Just 2 steps that you need. Okay, I'm just going to go with that. Is there another way to find R2, an easier way? Not really seeing another easier way. There may be, but I'm not really seeing it right now. So I'll just go with that. Okay, so how can I find angle R2? And this is something I was actually thinking about when I remember they said something about a line bisecting. Okay, they specifically said that. Okay, so the thing is, I wanted to use the fact that they said SR bisects chord PQ, but now I realize that they just said SR bisects chord PQ. They didn't necessarily say it bisected this angle, because then I would have just said, oh, then that means if it's cutting this angle into half, if this is 62, then R2 is 62. But I don't think I can actually do that because they didn't say it bisected that angle. They just said it bisected PQ. So I'm going to use another way of finding this. Instead of finding angle R2, angle S is at the circumference. So if we can find another angle at the circumference that is also being supported by RQ, then those would be equal. So you see this angle P, it's also being supported by RQ. So it means that these two are equal. So we just have to find angle P. And angle P looks actually easier to find because there's 62 degrees there. There is this angle, 90 degrees, and we can find angle P. So I'm just going to say that angle P, you can say plus 62 if you want, plus 90, that it's going to be equal to, because it's a triangle, 180 degrees. Then I'll leave angle P as the subject and say 180 degrees minus 90, of course, minus 62, which is really just angle P being equal to 90 minus 62, if you think about it. Okay, so angle P is equal to 28 degrees because of the angles inside a triangle. Okay, so the angle in that triangle, we found angle P. So angles in a triangle, sum of angles in a triangle. Okay, so that's my reason. And now I can find angle S. Okay, using the fact that we have angles at the circumference supported by the same chord are equal. So angle P is equal to angle S. Okay, so that means finally that angle S, I should have just said angle S is equal to angle P. And so finally angle S is equal to 28 degrees as well. Okay, so that is that question. We're done with question 9.2 and moving on to the next question. Okay, so question 10. Question 10, this is what we have. They say, the largest circle ADBF with a center O intersects the smaller circle at F and B respectively. Okay. Then we have points O and E also lie on the smaller circle with FED and AOB joined, and we have angle D1 is equal to X. Okay, so we have a bigger circle. It is intersecting the smaller circle, and as you can see, O, which is the center of the bigger circle, is one of the points on the circumference of the smaller circle. Okay, and then they just told us that angle D1 is equal to X. Okay, the fact that they're already calling this X, this is the type that does not have numbers. They're going to ask you for things and they're going to probably be in terms of X. Okay, the first question is you need to determine two other angles each equal to X. Two other angles that are equal to X. Okay, let's go. Okay, so we don't have tangents here. That's one thing you should see. We do not have tangents. However, do you see that in this big circle, right? If you look at where X is, it's at the circumference. And that's the thing. You should always look at where is this angle? It's at the circumference. So apply rules that speak about angles at the circumference. So I would have used the angle at the center is twice the angle at the circumference, but I'm not going to use that. The reason why is because they want two other angles that are equal to X. Okay, not two other angles that have X in them. So we need to find whatever is actually equal to this. So I'm going to use the fact that AB is supporting angle D1, but AB, sorry, why do I keep calling this AB? It's AF, sorry. AF is also supporting this angle at the circumference, which is angle B1. So those will be equal because the angles at the circumference or angles in the same segment. Yeah, that's a shorter reason. Angles in the same segment. So I'm just going to say angle B1 is also equal to X. And the reason is angles in the same segment. Okay, and then what else is equal to X? So this is X. You always good to put it down because it's going to help you with the next one. If this is X, what else is X? So I used the bigger circle before. Look at the smaller circle now. You see that X is also at the circumference of the smaller circle. See? And it's being supported by the arc OF. Do you see another angle in the smaller circle that is supported by that same arc? I also see one. So here, if you see OF, that chord really, you see that angle E is also supported by OF. So it means that these two would be equal. So the angle E1 is also equal to X because of angles in the same segment as well. So we can also just say that an angle E1 is equal to X, and the reason is exactly the same. So there, those are two other angles that are both equal to X. Moving on to the next question. Just make sure to always write down what you have found. These two are now X. So I can erase all of these, but that's X and this is X. It's probably going to help you with your next question. Okay, next question. Determine with reasons the following angles in terms of X. And the first one is angle O1, which is what I was speaking about at first. Angle O1, remember, angle O1 is supported by AF, that arc AF, and angle D1 is also supported by it. So angle O1 is the angle at the center, and this is the angle at the circumference. The angle at the center is always twice the size of the angle at the circumference if they're supported by the same chord or arc. So that means that angle O1, since this is X, angle O1 is going to be 2X. Okay, so that's my thing. Angle O1, and just say it's equal to 2X here. And then my reason is that angle at the center is twice the angle at the circumference supported by the same arc. Okay, and here I'm just going to specify the arc. So the arc I'm speaking about is AB, AF. I keep calling this B. AF, okay, arc AF. So there, and that is that. Moving on to the next question. Okay, the next one is OFB. I guess that was supposed to be a cap there. Angle OFB. OFB. Let's see where that is. That's O to F to B. Okay, we have to determine the size of that angle. Okay. Instantly I'm already seeing something here. I see that we have a triangle. Okay, and an exterior angle. The exterior angle of a triangle is always equal to the sum of the two opposite interior angles. Meaning, if I take angle F, the whole of angle F, and I add it to the angle B1, it's going to give me that exterior angle, angle O1. Okay, practice is what's going to help you get there. You're going to have to continue practicing on past papers, checking the memo if you're right. Make sure not to rely on the memo. You need to only check the memo when you have actually done the question, you've done everything you could on the question, and you maybe want to check the answer, or you really don't know what the answer is anymore. But you need to make sure you understand the question and actually work on it. Okay, so that's what I'm going to do. I'm just going to say that I'm going to find angle F1 like angle F like this, or OFB. That's what they called it. So I'm saying OFB plus this other interior angle, angle B1, which is X right now, that is going to be equal to the exterior angle, which is 2X, or angle O1. So let's use that formula and that equation, and find angle OFB. Okay, so now that we have this, remember what was the reason for that? That was because the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Okay, so that's down. And so now we just have to find OFB, which is equal to we'll just take the x over. So that's 2x minus x, which is just equal to x. So there, that is angle OFB. So I'm also just going to make sure to put it down so that I know that we have this angle. This is x. Okay, next question. So next we have to find angle D2. So angle D2, let's see. Angle D2 is over here. Okay, instantly I'm already seeing that. You see, because I'm looking at the fact that it's at the circumference and I'm like, I already have this one. So if it's at the circumference, I already have this one and I'm seeing this. So I try to just like extend it down with my eyes, of course, with my eyes. And so then I see that, oh, this is a diameter. So it means that this is 90 degrees since this is a diameter, okay, of the bigger circle. So it means that angle D1, if you take angle D1 and you add it to angle D2, that it's going to give you 90 degrees. But I know that angle D1 is x and angle D2 is what I'm looking for. It's equal to 90 degrees. Then I'll just take x over, so angle D2 is actually equal to 90 degrees minus x. And our reason is because that is 90 degrees, okay? So it's the angle in a semicircle. So there we go. Okay, so that's 10.2.3. Moving on to the next question. Okay, so 10.2.4 says angle E2, we have to find the size of angle E2. Okay, after finding that. That one is 90 minus x. Just make sure to always be putting them down because they will help you. 90 minus x. Now we have to find angle E2, which is over here. Okay, and I'm already seeing a way to find it. So we could find angle E2 like this. I'm seeing that in the smaller circle. Do you notice that angle E2 is at the circumference, right? Though we don't have a center here, that's fine. Angle E2 is at the circumference and it's being supported by this chord BF, right? I also see another angle supported by BF, which is this angle over here. So it means that these two angles would be equal to each other. Angle E2 will be equal to this angle. So all I have to do there now is if I can just find the size of angle O2, then I'll be able to find the size of angle E2. And the size of angle O2 is not bad to find because do you see that O1 and O2, they lie on a straight line. So they add up to 180 degrees. So in this one, I'll start off by saying that angle O1 plus angle O2 is going to add up to 180 degrees. And because of angles on a straight line, and then I'm going to say 2x plus angle O2 is equal to 180 degrees. Then angle O2 is equal to 180 degrees minus 2x, right? So that's O2, 180 degrees minus 2x. And then after I've done that, because these two are at the circumference supported by the same chord in the smaller circle, they would be equal. So it would mean angle E2 is also equal to 180 degrees minus 2x. Okay, and you must just make sure you put your reasons for both of them. Okay, so then remember that was angles on a straight line, and I'm just going to rewrite the rest that I wrote like above. Okay, and then we're talking about angle E2. Angle E2, remember, they're going to be equal to each other because these are angles in the same segment. They're supported by the same chord. Okay, so angle E2 is also equal to 180 degrees minus 2x because of angles in the same segment. Okay, so that one is done. Moving on to the next question. And the next question says 10.3, prove with reasons that EB is equal to ED. So we have to show them why these two lines are equal. EB equals ED. Let's go ahead and see which lines exactly they're speaking about. Okay, why would EB be equal to ED? Okay, we have to prove it really. In order to find out, now it's not bad because it's part of a triangle. Here's something you need to know about a triangle. If you have a triangle, right, and two sides in the triangles are equal, then it would mean that two angles, okay, the opposite angles would also be equal. Likewise, if you have a triangle and the opposite angles are equal, it would mean that the sides opposite those angles would also be equal, right? So it means that this side is equal to this side. So what I'm saying in this one is, if we can show them that B3 is actually equal to D2, then it would prove that EB truly is equal to ED. Because if the two angles are equal like that, then the sides opposite the angles would also be equal. So really, we're trying to just find the size of angle B3. And naturally, it should be equal to this, the same size of angle D2. So how can we find B3? Let's just look at where it is. I would have said exterior angle, but it doesn't extend, so it's not going to work. Let's see, B3. What else can we do? I am seeing exterior angle of a triangle, however. Okay, so I'm seeing exterior angle of a triangle. Exterior angle of a triangle. See, look at this line and then look at this triangle. The exterior angle of the triangle is always going to be equal to the sum of the two opposite interior angles. Okay, so with this one, I'm already going to put the calculation here so you know I don't have to keep scrolling up and down. So what I'm going to say here is this exterior angle, angle E2. Well, let me just say add the two angles. So I'm saying angle D2, this angle here, plus angle B3, this angle here, will be equal to the exterior angle, which is angle E2. Okay. And then I'm just going to fill in. Angle D2 is 90 degrees minus X. Angle B3 is what we're looking for. And angle E2 is 180 degrees minus 2x. That's why it's important to fill in when you find something. 180 degrees minus 2x. And all we have to do here is just make angle B3 the subject of this formula. So angle B3 is equal to, and I'll just say 180 degrees minus 2x, and I'm going to take the negative x over and it becomes a positive x. Then I take the 90 degrees, positive 90 degrees over, and it becomes a negative 90 degrees. So angle B3 is actually equal to, like terms together, so 180 minus 90 is 90, and negative 2x plus x is negative x. There, you see, naturally equal to that. Okay, so I'm put this calculation down first of all, and my reason for this is exterior angle of a triangle being equal to the sum of the two opposite interior angles. Okay, so there you go, just as we had it here with the reason as well. And now finally, because you can see now these two angles are now equal to each other, B3 is 90 degrees minus x, D2 is also 90 degrees minus x, we have the opposite angles. Okay, we have these two angles, the base angles being equal. So it means that the sides that lie opposite the angles would also be equal. Okay, so there we'll be able to say that EB is truly equal to ED. And the reason for this is not isosceles triangle. Okay, it's not because you have an isosceles triangle. It kind of is, but the reason that you would use is that the angles opposite equal sides would be equal. Or you could also just say the sides opposite equal angles are equal, the other way around. So I'll just say sides opposite equal angles are equal. Okay, but of course first I will conclude that those two angles are equal, that angle B3 truly is equal to that angle over there, which is D2. Okay, first I have to conclude that equal to D2 because we found it, and then finally I can just go ahead and tell them EB is equal to ED, and of course put the reason. Okay, so there we go. And that is the last question for question 10. And then we move on to question 11. Okay, so question 11, we have a similar thing to what happened in question 9 as well. So they say 11.1, in the diagram, chords SR, RT, and ST are drawn. So they form a triangle. Okay, are drawn in a circle with the center O. Then they tell us that DSL is a tangent to the circle at S. And they want us to use the diagram on the attached answer sheet D to prove the theorem which states that the angle between the tangent DSL and the chord SR, right, that angle in between there is equal to the angle in the alternate segment. That is, prove that angle LSR is equal to angle T. So you need to prove that the angle here is equal to the angle here. Okay, I have a proof on this again on my channel. You will also you'll be able to see the proofs with the pictures, the thumbnail on it. It's really just the circle and you have a tangent to it. Okay, so we can go ahead and start with this. I'm going to just use that answer sheet D. Okay, answer sheet D is not completed. Okay, you just actually have to prove this one yourself. So please make sure you study all your proofs. You see now in this one paper, 2 proofs came in. Proofs will always come in, and you see this one costs like 6 marks. So that's a place that you can really score marks. Make sure to study your proofs. Okay, so we just have to prove that LSR, that angle, is equal to this angle. So I'm just going to say to prove, that's what I have to prove. LSR is equal to angle T. That's all. Okay, so first of all, we're going to start like this. You are going to draw a line. Okay, you're going to join the line from the center to the circumference. Okay, so in other words, it's a radius. We're just sketching that. And then there's something else that you also have to draw in order to be able to prove this theorem. But really what we're actually doing is we're actually drawing a diameter, not just a radius. So connect O to S, but you're also going to connect a new line like that. So we will describe that as a diameter. You can call this point anything. So I'll just call it P, because P is not really used here. So in my construction, I'm going to tell them that I constructed diameter SOP, or I extended SO, right, to P. And it's a diameter. Just make sure you let them know what you did. Then the second thing I'm going to do is from this point P, I'm going to join that to T. Okay, so those are the 2 constructions that you need to make. Okay, so for my construction, I'm just saying I am constructing a diameter SOP and a line PT. Okay, so now we can start proving. But you also have to just name certain angles. We're going to call this angle over here angle S1, and this one angle S2. And here, because you see you're trying to prove that this angle is equal to this angle, I'm going to call this angle T1 and this little part here T2. Okay. Now, with that being said, just because I also, you're going to submit this, so it's fine. You don't have to start telling them that this angle is called S1. You don't have to tell them RSL is equal to S1. You just have to actually write the numbers down. So we can start with proving. The first thing to do when proving this is we're going to use the fact that this is a tangent and this is a radius. OS is a radius. Remember that the tangent is always perpendicular to the radius at the point of contact. You see, so throughout this paper, I'm seeing a lot of repetition. They're using a lot of the same theorems. Okay, so that's what I'm going to say first. OS is perpendicular to LS. If you like, you can say DL. That's still fine. So I'm just going to say OS is perpendicular to, okay, DS. I'll just call it LS. It's fine. LS. And my reason for that is that the radius is always perpendicular to the tangent at the point of contact. So I'll just say radius perpendicular to tangent. Okay. And what can we conclude from this? Well, if they are perpendicular, then it means that angle S1 plus angle S2 would give you 90 degrees. Okay, that's going to be a very important thing. Angle S1 plus angle S2 is equal to 90 degrees. Okay, and we hold that and we keep it. Then we're going to look at this part as well now. Do you notice that SOP is a diameter? So if SOP is a diameter, then diameter always supports, the angle it supports at the circumference would be equal to 90 degrees. So it means that if you say T1 plus T2, it should give you 90 degrees. So I'm also going to note that down, that angle T1 plus angle T2 is going to be equal to 90 degrees. And my reason for this one is because of the angle in a semicircle. We have a diameter supporting an angle at the circumference. So angle in a semicircle. Okay, now that we have that, in order to prove that this angle is equal to this angle, look at what we can do here. Do you realize that if you tilt your head, look at the arc RP and look at the angles at the circumference that it is supporting. RP is supporting angle S2 and it's also supporting angle T2. So what does that mean about those two angles? that they are equal. So I can say that angle S2 is equal to angle T2. Angle S2 equals angle T2. Okay, and my reason for them being equal would be angles in the same segment. Okay, now that I've stated that these two are equal, here's why I was doing that. Okay, this is the whole point of saying that they are equal to each other. It's because of this. Do you see that in these two equations that we have created, we've created two equations here. This first one and the second one. And both equations add up to 90 degrees. But now we found that in these two equations, S2 is equal to T2. So that's kind of like, imagine this was 30 degrees, right? Then it would mean T2 is also 30 degrees. Then what would that make S1? It would make it 60 degrees. And because this one is also equal to 30, this would also be 60 degrees. Do you see now, because we have two angles being equal there in those two equations, it by default makes these two angles equal as well. So now, because of this, we can conclude that this means that angle S1 is actually equal to angle T1. Okay, there's no reason for this, it's just a conclusion because of the fact that those two were equal. And look at what we've just proven now. We've proven that angle S1, this angle, is equal to angle T1, that angle. That's what they asked us to prove, that angle LSR is equal to angle T. And we've proven that. That's angle T. So there, because of that, I'm just finally going to conclude that angle LSR, because that's what angle S1 is equal to angle T. Okay, so there, that's how we prove that theorem. Please make sure to study your theorems because it's really going to help you. You see, 2 theorems came in this whole paper. Moving on to the next question. Okay, so 11.2, we have this. They say, okay, this is the last question. TA, they say TA is a common tangent to the circle CBA. So CBA, the smaller one, and FDA, the bigger one, at A. Chords AC and AD are drawn with BCD a tangent to the circle. So you see, I don't really care too much about chords. I mean, sometimes they're important, but they mentioned the tangent. So that BCD is a tangent to the circle. BCD is a tangent to the circle at D, that big circle. Okay, so let's see what we can do with this. Only 2 questions, but the last question is what 7 marks. We'll see. Okay, so they said provide the geometric reason that angle D1 is equal to angle F. Let's see. It's only for 1 mark, so it's probably just the one-step thing. Why is angle D1 equal to F? Oh, okay, so we have a tangent. We have a tangent here at the big circle, okay, to the big circle. And do you see that there is a chord, DA? So the angle between the tangent and the chord is equal to the angle opposite the chord, or really the angle supported by that same chord. Do you see why those two are equal now? You see, they keep they keep repeating things, like something that they would have worked on in the previous question was literally about the angle between the tangent and the chord. And the first question immediately here was using that theorem. So you will notice that a lot. Okay, so yeah, they just say give a reason. I don't have to say they're equal, I just have to give them a reason. It's because of the angle between the tangent and the chord. Now, I don't know if your teacher accepts tan chord theorem, because they used to, but then I think in grade 11 it's still fine. They don't mind. I know that in round about 2018, I was in matric then. So they gave a new rule where they said you are not allowed to write in shorthand. I don't know if they continued with that or they changed their mind on it. But in grade 11, it's fine. We can just say tan chord theorem. Okay, so there. Because of the tan chord theorem. That's the reason. And now that 7 mark question. Okay, let's go. Okay, so that last question, that 7 mark question says, prove that angle A1 is equal to angle A2. This is going to be interesting. Let's see. Angle A1 being equal to A2, but I'm also going to note that these 2 angles are equal. If I'm being honest, I don't like writing these angles as, oh, this is equal to this and then done. I do, however, like to just call it a specific letter, like I will assign a letter to it. I can say let angle D1 be equal to X. That way I can monitor it. I can monitor whatever is equal to angle D1. Okay, so right now we know these two are equal, so I just call them both X just to monitor it better. Okay, let's see, angle A1 and angle A2. You can also assign a letter to it. So the thing about this is you can start from either angle A1 or you can start from angle A2. And you just have to find a way to get from angle A1 to A2. So what I mean is you could start from angle A1 and find out that maybe angle A1 is equal to angle C1, for example, right? I'm not saying it's equal, I'm just saying, for example. And then you find that angle C1 is maybe equal to angle D2. Then eventually you find maybe angle D2 is equal to angle A2. You see, it moves around. That's why I try to name it something. So within this context, I'm going to name this Y and I'm going to call that one X because I don't have any reason to say that they are the same thing yet. So I'm going to actually say that first. I'm going to just say, for the sake of following that properly, let angle D1 be equal to X and angle A1 be equal to Y. But you have to be careful when naming this. You see, you can either start from A1 or you can start from A2. Choose the one that looks like it can move around better. Let me just see which one looks like it can move around more freely. Okay, so since we've done that, now I looked at this thing for a while, and what I'm starting to notice is because they only gave us tangents, you see. They gave us this tangent, and let's just look at the tangent specifically that they gave us. They gave us this tangent. They said that this one is a common tangent, okay? So it's a tangent to both circles. Notice that if it's a tangent to both circles, then this angle over here in the smaller circle, the angle between the tangent and this chord in the smaller circle would be equal to this angle. Okay, now I don't want to start just looking at it as finding random things, but in this one, like I usually say, even in the grade 12 past paper videos on Euclid, you find these angles not by guessing. Okay, you don't find random things. There's actually a strategy to it. So because I knew that I want A1 and I also of course want A2, but they're supposed to be equal, I'm not going to make them equal to each other. We need to prove that they're equal. So my focus was I need to be finding angles at least within this region. The reason why is because I could either use angles around a point or at least angles on a straight line. So I was trying to find angles within this region. And while doing that, I started noticing that I can first of all find, so remember that this angle over here, because we have a tangent, right? Let me even highlight that tangent again. Because we have this tangent here, I realized that this angle A4, right, would be equal to this angle over here, C1. So that brought me to C1. I was like, how can I find C1? Because if I find C1, at least I would have A4. So how to find C1? If you look at C1 and where it is, you see, when you look at an angle, you try to look at where it is in relation to the other shapes around it, the other angles around it. I noticed, first of all, angle C1 is at the circumference. And I was like, oh, maybe I could use one of the rules there. But this is not even a diameter. So I can't even use angles in a semicircle. And I also can't really use angles in the same segment because do you see that they didn't create anything that has lines crossing all throughout the shape? They don't have any lines crossing in the entire circle. So instead, what I decided to do is look at the fact that this is a flat line, okay? Meaning you have a flat line, and this line, if you connect it, you see that we have a triangle that is a part of this flat line. So I see now exterior angle of a triangle. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. You see why I named those things, because it makes it less confusing. So I figured that means that angle C1 is going to be equal to angle D1 plus angle, I'm going to call that A1, angle A1. Okay, and let me also just put that down quickly. Okay, because it's the exterior angle of a triangle. Okay, so now that we have that, we can go ahead and say that angle C1, so angle C1 is going to be equal to the opposite interior angle. So D1 is X, and I called A1 Y. So there, okay, X plus Y. So we have angle C1 being equal to X plus Y. So now that that is equal to X plus Y, so if this is equal to X plus Y because of the exterior angle of a triangle, remember that this is a tangent over here. AT is a tangent. So if AT is a tangent, then we also have a chord AB. This angle over here would be equal to this angle over here because it's the angle between the tangent and the chord, and it's equal to the angle supported by that same chord. So I can say that angle A4 is also equal to X plus Y because of the tan chord theorem. Okay, so now that I have that, angle A4 is also equal to X plus Y. So remember, I kept trying to find angles within this region. Then, as I was looking at this as well, I also noticed this. And now, using the fact that I have this, I can actually find angle A3. Okay, so if I find angle A3, and this is the reason I'm trying to find angle A3 now. If I find angle A3, notice that angle A3 is between the tangent and this chord. So it's going to be equal to the angle supported by the same chord. So the angle D2. These two angles would be equal. So if I find this one in terms of X and I'm able to find this, then I can use the fact that this is a triangle to find A2. And so naturally A2 should be equal to A1. Okay, so that's what I'm going to do there. I'm going to go ahead and find A3 first. And I'll find A3 by seeing the fact that we have a straight line. So the angles on the straight line add up to 180 degrees. So to find A3, I'm just going to say that X plus Y, which is that angle there, X plus Y, plus angle A3 should be equal to 180 degrees. Then of course say angle A3 is equal to 180 degrees. Then take X over minus X, take Y over minus Y. So that's what A3 is. It is 180 degrees minus X minus Y. Okay, let me put that down and the reason. Okay, and the reason is there because of the angles on a straight line. The sum of angles on a straight line equal 180 degrees. And this is A3, okay. So now that A3 is there, you see I'm going to use the fact that we have a tangent AT. And so angle between the tangent and the chord will be equal to the angle supported by the same chord. So it means that D2 is equal to A3. Okay, so angle D2 equals angle A3 because of tan chord theorem, and D2 is equal to angle A3 because of the tan chord theorem. And so that means now that angle D2 is actually equal to all of this again, 180 degrees minus X minus Y, right? And now that I have that, make sure you just put that down, 180 minus X minus Y. And now that I have this angle, I can use the fact that this is a triangle. And I can use that to find angle A2. So if I take angle A2 plus angle D2 plus angle F, it should give me 180 degrees. Okay, so I can use that. In other words, it means that if I have A2, if I want to find A2, I have to say 180 degrees minus angle D minus angle F. Okay, and I mean angle D2 there. Okay, so angle A2 would be equal to 180 degrees minus angle D, which is all of this. But you see, you have a minus. So you have to respect that and put a bracket. And we're saying 180 degrees minus X minus Y. Okay, so that's minus angle D. This is the whole of angle D. Then minus angle F, and angle F was equal to X just on its own. So minus X. Now let's just clean this up a bit. So this is 180 degrees, and if we multiply and distribute in, really, minus 180 degrees, then distribute that. That's plus X and plus Y. And then outside the bracket, we just have minus X. So angle A2 is finally going to just be equal to, as you can see, 180 and 180 would simplify to 0. X and X would simplify to 0. And we can see that angle A2 is equal to Y. Okay, so now that we know angle A2 is Y, remember I said let angle A1 be Y, and angle A2 ended up being Y. So you're also going to say, I'm just going to make it seem like a conversation. So I'll say, but angle A1 is equal to Y. So that means that angle A2 or angle A1 is equal to angle A2. And there we go. So that's how it works. You see, it's not something that you just guess. There is a strategy behind it. My strategy was I needed to find that angle and make them equal, right? Show that they're equal, not making them equal. So I decided to focus around this region in attempt to use the angles on a straight line. But you see how that led me into actually using the angles in a triangle, and I was able to find that. You need to have some sort of strategy. If you just guess, the chances of you getting it right is not very high. It's not impossible to get it right. You could, but the chances are not that high. Okay, so that is the end of this paper. I hope you guys understood it. If you do enjoy this content, please make sure to like the video. It really helps the algorithm, and subscribe for more content. And I will see you guys in the future videos. Bye.